Hi everyone, I'm back. So it seems like one person, I'm not sure where they are. I tried calling them. I'll just share with them the recording when I'm done. So um, we can proceed. Please let me know if you can hear me.
Yeah, I can still hear you.
Okay, cool. Kazmulo, can you hear me?
Yeah, yeah, I can hear you.
Okay. Yeah, I guess we'll just continue and then I'll share the recording with the other student. Okay, let me share my screen. Did you guys go through the code that we did during the day and in the morning?
I went through it, but on mine, I only have the first one.
You
I
only
don't
have.
have the entire code, so I only went through the parts that I could find.
Oh, the first one you mean what? Like main?
I think I have the .cpp file, the one for if not defined, then defined. That's the only code that I have.
Oh, okay. So how about you? How did you also not have the other code?
Yeah.
It's also not there in your one as well.
Yeah.
Okay. And to me, was it the same thing? So guys, if you look at the file that I sent you guys, there should be like if you check the file itself, are you saying that there's no ujradars.cpp?
No, there's also no main.cpp as well.
There's also no what?
The, the main.cpp is also not there. It's just a .h file.
Oh, okay. I wonder how I sent it. Let me see what's zipped. It should be there, guys. Did you try and look inside the folder?
Let me look inside now.
Yeah, please try and look inside the folder. Like, what's inside the folder?
No, I think it's there.
Oh, it is there. You just maybe it's the imports, right? You guys couldn't like put it into your project. Okay. Okay. Cool. But I did send everything. You should have mentioned this earlier on so that I assist you guys open the project. But it's fine.
Can you just quickly navigate to how can we like link up these three files
How to link them up? Let
in
me
code
see.
block?
How do we link them up? Go to. Let's see. I forgot the actual functionality of linking them up, but right click here and say add files recursively. Right click to st2r and then say add files recursively, and then just say select folder afterwards, and then you find those files that you need. So you should select UJ H and UJ CPP, and then the
Can you
CPP.
please repeat the process then?
So right click st2r and then say add files recursively, and then you should select folder afterwards. Then you will see something like this, and then you'll need to find main.cpp, UJ Raiders CPP, and also UJ Raiders H.
Okay.
Yeah, are you able to? Are you winning?
Yeah. Yeah.
Kazmulo, how about you?
Yes, I was able to find them.
Oh, okay. Did you manage to open them also in code blocks?
No, I didn't try it on code blocks. Let me try it now.
Okay, cool. Yeah, if you struggle, just let me know. I'll wait for you. And I'm not sure about Dumi if you can hear us. Did you manage to find the files that I shared with you guys? Okay, it seems like I'm not sure if Dumi's mic is working or not. But yeah, anyways, should I wait for you, Nkazmulo?
Oh, no, it's fine. You can. Oh, mine are opening on Visual Studio. Let me just.
Oh, okay. Just try to open
Yeah.
them in code blocks. Do you use Visual Studio when you're writing or your pregs?
Oh no, I use Visual Studio for informatics.
Oh, okay, okay. No, I see.
Yeah.
Okay, cool. So,
Okay.
yeah, anyways, we will continue from where we left off and then try and complete everything. So, the command line, I think we did initialization, and then we also managed to add the towers on each row. We managed to add one tower on each row, and that was the last thing that we did. Okay, so I'm gonna look at yeah, I'm just gonna take questions now. If you guys went through the practical and maybe there's something that you did not understand that you made note of earlier on today, you can just maybe let me know, and then I'll see how I can address those. So yeah, I'll just give you guys some time to ask questions. Okay, so you guys, I assume you guys don't have any questions. Let's proceed. So, looking at the second part, right? Each row in the world area has one charging tower. We were covering this logic, and I did explain to you guys. I did mention that most of the things that we're gonna be doing from now on going forward, it's basically logic. You're just basically playing with the grid. So I did use this Excel as an example to say that if these zeros are trees, we would place random trees everywhere in each row. So something like this, 1 1 1 1 would basically us generating those random numbers for our towers, and actually placing the random towers in at least one in each row. So in this row we're gonna place it here, in this row we're gonna place it here, and so forth, right? So if I run now the program, you will see that we have our grid with at least one tower in each and every row, and these towers are placed randomly. So basically that covers the second bullet in our initialization. So now moving on to the third bullet, right? The command line defined map pieces are scattered randomly throughout the world area, right? What does that mean, right? What does that mean? It basically means that we're gonna have the map pieces which are scattered throughout the world area, right? So the map pieces are initially hidden and do not appear. The map pieces cannot be placed on top of each other or on charging towers, but can be hidden below a tree. So what does this mean? What do you guys understand about this part here, where it says that the command line defined map pieces are scattered randomly throughout the world area? What do you guys understand about that?
I think the way it will just like disperse the number of map pieces according to the command line randomly like in the grid, but I'm not quite sure how like
We're gonna do that.
they, they will be able to like hide them. That's the only part I don't know. How are they going to hide them?
How to hide them. Okay. Okay, I understand that. So don't worry about it. We will find a way. We'll basically apply logic to that as well to actually hide them. Anyone else with anything else to maybe add? Nkazmulo, do you have anything to add on this? Point here.
I just don't. I feel like I don't really understand because the trees are everywhere,
Okay.
but also the charging towers are there. Does it mean that the charging tower is also where the tree is? Or
Yes.
like-
So let's look at the previous bullet where it says that each row in the world area has one charging tower located in a random column, right? Charging towers override any trees in that location. So what does that mean? That means that if there's a tree in a grid, it's gonna be overwritten by a charging tower if maybe we found a row and a column for the charging tower, which is why we have T here. So initially, remember when we did our initialization, we had trees everywhere, and then after that, we placed charging towers in a random column in all the rows. So basically what happens is that when we find a column for the row 0, we're gonna put a charging tower instead of a tree.
Okay.
Yeah, so that's what it means. So now that you know, now that you have found, I'm hoping that you have found on this part, in terms of the command line defined map pieces are scattered randomly throughout the world area. What do you sort of like at least have an understanding of what they're trying to say?
Yes. So
Okay.
does it say how many there are? Since with the towers they said that there was one in each row. So the map pieces, does it matter how many there are in the
Yes.
world?
It does, because they say that the command line defined map pieces. Remember that when we were doing our main, we had rows, calls, enchants, and then int map pieces, which is
Yes.
basically the number of the map pieces that are in the world. So these are the number. The number is basically this value here.
Oh.
Yeah.
Okay.
Yeah. That's why they're saying that the command line defined map pieces are scattered. So command line defined. So basically they actually we specify these map pieces in the command line. So that's argv4 in this case.
Oh.
So are you still lost?
Oh no.
Okay.
No.
So now let's go to this. So now if we know that they are scattered randomly throughout the world area, we know that we're gonna have to generate random rows and random calls for all of them. So each and every map piece is gonna have a specific coordinates or rows and calls. So if we look at our grid, so now I'm gonna say 1. Wherever there's 1, this is your charging tower. Wherever there's 0, it's basically your trees. And now what they are telling us is that if the user will specify how many map pieces will be in our world, we're gonna scatter them randomly everywhere, right? So let's just do this, and then this. So these are the charging towers, 1 in each and every row in a random column. So now we also have what we call map pieces, which are gonna be scattered everywhere. So now if the user entered 10 map pieces, it means that we'll have to find 10 random columns and rows, right, such that they do not overlap. So if now I come here, I say 2 is a charging tower, it's a map piece, and also this is a map piece. So wherever there's 2, it's basically gonna be our map piece, right? So let's say we have 1, 2, 3, 4, just make it 5. So we have 5 map pieces. What they're saying is that we cannot put them on top of each other. We have to make sure that they are everywhere else, but not on top of each other. That is what this line says here. Map pieces cannot be placed on top. So map pieces cannot be placed on top of each other. Or also, so the map pieces cannot be placed on top of each other, or on charging towers. So it's two things here. We cannot place them on top of each other, and we cannot place them on charging towers as well. So we have to make sure that when we are applying our logic, we don't place them on top of each other, and we don't place them on top of the charging towers, but can be hidden below a tree, which makes sense. So what does that mean is that in our world we have obviously trees everywhere and also charging towers, but then we don't display. I'm gonna show you guys how to hide and how to unhide the map pieces. So let's just go ahead and play and scatter around our map pieces. So I'm just gonna create a function. It should be a void because I don't expect anything from that function. I just want to scatter the map pieces around, just like there's a place towers here. It basically places the towers and it does nothing afterwards. I don't expect anything from it. I just wanted to place the towers. So for our scattering our map pieces, I can just create a function and call it scatter map pieces. It doesn't matter how you guys are gonna do this, but then as long as what you're gonna do will make sense. So it will take in the game world, and also let's see what else it's gonna take in. So for now it will take in the game world, and then let's see what's inside the game world. We do have that value. We did store that value inside our structure, the one that will have the total number of map pieces. And if you look at the initialization function, we did get that from the argument that is passed here, initialization. And if we go all the way back to main, we do see that when we call initialization, we are passing in the map pieces like that. Let me just do this so that you guys can see everything. I'll just do leave spaces. Okay, so yeah, we're gonna see that the map pieces is the fourth argument in our command line. And what is the fourth argument in our command line? It's basically 5. So we're gonna have 5 map pieces. So in our function for scatter map pieces, right, I'm gonna declare it here. This is the declaration of the function, and then I'm gonna come here and define it below the place towers function. I'm gonna define it here. So what this function will do, basically it will scatter our map pieces, right? Given that we do have the map pieces inside the game world, any ideas of how we're gonna implement this function? I just want to see how you guys would tackle this if you were to actually implement the function. Any ideas? You can just say something. You don't have to give me the code, but just actually try and give me like a pseudocode, like this is what I would do. Yeah.
Sir,
Yeah.
can you hear me?
Yeah, I can hear you. Any ideas?
I have mic issues. I just wanted to make sure.
Oh.
I don't know. Open like a for loop, just like you did, like placing the towers, and then
Yes.
introduce.
Can we not have something of like try to all by means like to show which is some of the spaces have already been taken up by another variable, maybe what is the tower?
By towers, okay.
And then-
Okay, yeah. No, sorry to disturb. Okay, I'll take 2 points. So you were saying we must introduce something, and then the first person, they were saying a for loop, right? So let's just first hear the full solution for the first person, and then we're gonna come to the second solution. And also I think Nkazumulo, you must suggest something as well, just so that I can also guide you in understanding how we're gonna actually implement this logic. So you were saying for loop.
Yeah, for loop whereby like it's for int if not int, if something is not a tree and that particular something is not a tower, then it is equal to a map piece and then maybe you introduce some sort of like a system since like you said in the instructions you can collect like the map pieces. You should have the option to collect the map pieces.
Okay. I'm gonna tell you what's wrong with your implementation. Actually, let me just tell you now, and then we'll move on to the second person. So,
Okay.
introducing a for loop, right? Um, it could work with a for loop, but then now we remember we're given the number of map pieces and want to put them randomly. So think of it this way, guys. Let me help you think in sense of in a way that you maybe are gonna understand how to actually apply logic into your code. So we have a grid, right? Don't think of C++ as yet. Think of a grid, right? We know that if we wanna print this grid, we are gonna use a for loop for each row and another for loop inside for each column. You guys agree with me there? So
Yeah.
so now let's say that you are given map pieces in your hand. So let's say we have a grid here. We can put any map piece that we have in your hand. So you literally have 5 things in your hand. Like let's say you have 5. Let's say a map piece. It's a map piece. It's 3, right? So you have 3. So you have 5 threes in your hand, right? So when you put 1 3 here, now you're gonna have 4, right? Then when you put another 3 here, now you're gonna have 3. Another 3 here, you're gonna have 2. Another 3 here, you're gonna have 1. Another 3 here, you're not gonna have anything. It's done. You're done placing your map pieces, right? And then if maybe you had 1 extra left, and then you wanna put another 3, and then you come here, you're like, okay, there's already another 3 here. I can't put it here. I have to find another space, right? I would go elsewhere, find another space, put a 3, then another space. So think of it in terms of the way I was showing you guys now, how, like, given that you have 3 map pieces in your, given that you have 5, right? So let me say map piece and then number, it's 5. You have 5, and then let's say this one here is like a label, right? Label. So given that this is a label, the label is 3. So if you want to put a map piece, you have to come here and say 3. You have to come here and say 3. You have to come here and say 3. Given that you have now 5 map pieces, right? Or total. Let me just call it total. So I want you to think of it in terms of, how you would do it. Given that you have 3 things in your hand, how would you do it? How would you place how would you place 5 map pieces on a grid? Like given that you can just click and place, click and place, click and place, how would you do it? It's not a trick question. It's like a straightforward question, and it's simple,
At the end.
right? So how would you guys place map pieces on a grid, given that you have map pieces in your hand, and then you can just literally, let's say this mouse is your hand. So when you say I would do it here, you just come here and then you place it, right? How would you do it?
Sir.
Isn't that we just gotta like say, let's say it was in the code, like can we use like a while loop to say like while in the location there's no tower, place the map pieces, and then maybe do another one to just to confirm if there's already another map piece, then move to another place to place.
Yeah, you are sort of like on the right path with the while loop, because obviously you need to loop through as long as you still have a map piece, right? So the question that I asked you guys, it's straightforward, right? I'll give you guys an answer of what I was asking now. It's straightforward. It's like I just need to go to a cell and click on it and then place a map piece, and then now I'm gonna have 4 left. And then I come again, I find another block, I place another map piece. Now I have 3, right? I come again randomly. Let's say I try to place here, I see that there's already a map piece. I'll look for something else. Here, I place, and then now I have 2 map pieces. I come again here, I place, and then now I have 1. And I come again, and then I place another map piece. Now I have 0. So I can't continue because now I ran out of map pieces. So even the logic that we are going to apply will be something similar to this, just that it's going to be in code. So you have to think of it in code, right? So what I was doing, it's same thing as generating a random column and a random row. Do you guys agree? Because it's random. I just picked here and then I placed. I placed. I came here, there was something, I moved on, I picked, I placed, I picked, I placed. So it's basically random. Do you guys agree that it's random? Because I didn't really start from here and then I placed step by step. I just picked with my hand. I just picked and then I placed. I picked, I placed, I picked, I placed. So the algorithm will work the same way, or the logic that we are going to apply will basically work the exact same way. There's nothing tricky about it. It's just going to be the same thing, right? So first of all, if I don't have any map piece, I can't continue looking for space because there's nothing that I'm gonna use, right? So how would we do it, right? I would do a while loop to check if while I still have a map piece in my hand, right? I would say while game world dot map piece dot int map piece. So while game world dot int map piece, I want it to run as long as I have map pieces, right? So it has to be greater than 0 because it means that this algorithm or this part of the code will run as long as I have map pieces, right? If I don't have a map piece, if map piece is 0, is 0 greater than 0? No, it's not. It's not gonna run what's gonna be inside. So while I have map pieces, I want to put them in a random row and a random call, right? So I'll have to find a random row, which I'll use the getRand function to generate a random row from 0 to int row -1, right? And then I'll also find a random call, which is what I was doing when I was pointing out here, that I'll just come here and place it, and then the number reduces the whole time I do that. And then int call is equals to getRand, and then 0, and then int call -1. So there's nothing magical here. I just generated a random row and a random call because they said that the map piece are scattered randomly. Here's another word, randomly, throughout the world area. So throughout, so everywhere, there's no restriction, there's no limitation whatsoever, right? So now after I generate the random row and a call, I want to check what is there, what is at that space, you know? So for example,
Sir,
yeah,
Fair.
can I ask?
Before you proceed, now what is the column doesn't no longer like come from a pointer perspective to say it's we first like search in the row and then go to the column of that row.
so a good question, right? Did I search when I was putting those map pieces here? Did I go here and then I went here, and or I just found a random row and a random call?
I think you just
I didn't
placing.
search, right? There's no need for me to search because what am I really searching? What am I looking for? If they say you have map pieces and you can just put them on a grid, it's not a trick question. There's no need for you to search for anything because you can search, but what are you really looking for? Because remember those 2 for loops. Those 2 for loops basically do this, and then when you're done, you go down, you do this, right? So if you are displaying the world, you have to go through each and every thing because you have to draw everything. But if now I have map pieces and I have to put them randomly, there's no need for me to search for anything, right? I just generate a random row and a random column. As long as I'm in the world, the numbers that I get are inside the world. Do you understand? Yeah.
It makes sense.
Yeah. So there's no need for me to search. I'm not searching for anything right now. So getRand from 0 until int row -1. What is int row?
So,
Yeah.
what happens when they say those map? Let's say like maybe it's a game, right?
Yes.
And then they say you must place a random not a random, a player. Let's say it's a player controlled game, and they say you must place the player in the center of the game when the game starts. I'm asking
How
how
would you do
you
that?
would, yeah.
Logic. I'm sure one of you guys can answer this. Am I lying? How would I place a player at the center?
Isn't that what's this?
I think that you would go by when you were printing out the world.
Uh-huh.
When you were printing out the world, I don't know how, but then somewhere there, you would say the player needs to be in the middle.
Oh, okay. It's also not a trick question. You guys are complicating it. You are overthinking everything, right? So let me do this. Find another grid. Um, let's say this is a tree, and this is a tree, and this is a tree, and then this is a tree, and then this is a tree, this is a tree, tree. Where's the center, guys?
It's in the middle.
Here.
In the middle. Yes.
19.
Yes. Right? So, in terms of rows and columns, where is the center? In terms of R, what is R?
It's row
Row
2,
2, column.
row 1.
Row 2, column 2.
Row 1, column 1.
Huh?
Row 1, column 1. Yeah, true. Because you remember we start from 0. This is 0, this is 1, this is 2.
Oh.
0, 1, 2, 0, 1, 2. Okay? So, right. So in relation to the world, let's look at the world. Like you have 0, 1, 2, right? So 0, 1, 2, and then 0, 1, 2.
Okay.
What is 2 divided by... okay, how do we get... What is the half? How do we get the half of 2? It's not a trick
Divided
question.
by 2.
We divide it by...
2.
Get a 1. So 2 divided... So, okay, let me just write this down. So row, I'm going to say row, rows, number of rows. So rows, we have how many rows? We have 3 rows. Calls, we have how many calls? 3 columns. You guys agree?
Yeah.
Yeah. So now, this is row 0, this is row 1, this is row 0, this is row 0, column 0, row 0, column 1, row 0, column 2. Same thing applies, column 0, row 1, column 0, row 2, etc. So if I want to find the middle point here on top, how do I find the middle point? How do I find the middle?
I see.
Isn't it supposed to be in row divided by
Would you
2?
like
I don't know.
you not what's this? Find the range and add 1.
Okay, find the range and add 1, right? That's yours. That's what you are suggesting, right? So what is the range in this case?
As in it's from position 2 zeros, then we get 2, then divided by 2 is 2, it's 1, and then add 1 for the location.
So yeah,
in the
also
middle.
use these values when you are doing the thing, right? So guys, to find half of to find half of a straight line, you basically find the total and then you divide by 2. To find half of everything, you divide by 2, right? So in this case, we have 3 rows and 3 columns. If we want to find half, we just say 3 divided by 2, which is 1.5, right? But that's not the point. The point is that you remember that the rows cannot be 3, right? They can only say 0, 1, 2. So if we say 2 divided by 2, we get a 1, which is here. And then if we say for calls, same thing, we apply the same thing. Because you remember the rows minus 1, you cannot go to the actual last part because we started 0. Now the tricky part is that we started 0. So to find this value here, we say the number of rows minus 1 divided by 2. And then it's going to give us 1. And also for calls, same thing, divided by 2. So if you were asked to put a player in the middle of the world, let's just try to do it here. Let's just try to do it here. So I'm just gonna leave this one for now, and then I'm gonna say let's put a player in the middle, right? So let's have a function, and then we're gonna say in the function void player in the middle, and then also let's say we give it the game world, and then game world. How we would do it, how we would put a player in the middle. So don't overthink it. It's simple. First of all, there's no need for us to go loop through the world. No, there's no need for us to do that. All we need to know is to find out how many rows are there and how many columns are there. So how many rows and how many columns, and then we divide that value by 2. It's simple, and then it's gonna give us the middle value. So if I were to do it, I would just come down to my function where I would put the player in the middle, and then I would say, okay, the middle, let's say middle row. I'm just gonna say int row for middle row, and then say game world dot int rows minus 1, and then I divide that value by 2. So I say divided by 2. Same thing applies to the int calls. Int calls is equals to game world dot int calls minus 1 divided by 2, right? And then let's put the player now there where we just define those things. So ARI world RC, we're just gonna put Q. I'm not gonna put Q because it's not gonna make sense. We're just gonna put 9. Let me put 9. And then I'm gonna come where I'm actually drawing my world. Where am I drawing my world? Where I'm displaying my world? Let's see, display world, display. Okay, display text in features. Okay, now instead of 9, I'm just gonna put in another thing. I'm just gonna introduce something. Say let's call it X or Q, and then we're also gonna put a mapping for it, because if you're gonna put it here inside the enum, it must also map like this. So Q, and then I'm just gonna say here that it's gonna be Q. Where is the put player in the center? Yeah. So I'm just gonna say here gonna be Q. Are you guys lost? With what I did here, I basically found the middle, and then the middle calls and the middle rows. So if we go back here, what I did was that I found this middle part here, right, by dividing. So for rows, I just said 2 divided by, because it's 3 rows, right? So 3 rows, but then we start counting from 0. All I said was that 3 minus 1 divided by 2, which gives us 1. This is row 1. Right?
Yeah, it makes sense.
So row 1. And then let me just, maybe if I label them, you guys are gonna understand. Row 2. Then call 0, call 1, call 2. Maybe if I do this, you guys are gonna understand. So there are 3 rows, right? 1, 2, 3. But we start counting from 0 all the time with arrays and in C++. Also 3 calls, we start counting from 0. So if I want to find the number, the middle, the row, the middle row, row 1, I just say total number of rows. So total number of rows 3 minus 1, right? And then I'm gonna divide this by 2. This will give me the middle point, because we'll get 2 from, we'll get 1 from this. Are you guys following? Yeah. So what I did here, I basically did the same thing that I just showed you guys. Total rows minus 1 divided by 2. Total calls minus 1 divided by 2. We got that middle part, we put Q. So now, if I run this, given that it doesn't complain, it says R was not declared. Of course, R was not declared because I was supposed to say int row instead, because there's no R and there's no C here, and then int calls as well. So if I recompile, it's complaining here because intro, of course it doesn't, it's intros and it's int calls. But let's focus on this. Recompile, it's fine. And then we were supposed to see Q in the middle. So why are we not seeing Q in the middle? Let me just try to see, because we did not call the player in the middle function. So we do have the function, but it's not yet called. So we're gonna go to the main, and then before we display, we're gonna call player in the middle, then we're gonna pass it our world. So let's rerun, and then we have Q. Is Q in the middle? Can you guys confirm? Is it in the middle? 1 2 3 4 5. 1 2 3 4. It's not in the middle, right? Let's try to understand why it's not in the middle. It's simple. So 1 2 3 4 5 6 7 8 9 10. 10 does not really have explicit middle, right? You cannot say 5 is the middle, because okay, if there's 5, there's okay, let's say 5. 1 2 3 4. 1 2 3 4 5. So there's no like middle, if you guys understand what I'm saying, right?
Yeah.
But if I come and do something like this, let's just find, let's say 11 and 11. Let's say instead of 10, it's 11 and it's 11, right? So 11 and 11, are we in the middle? Let's see. So we have 1 2 3 4 5, and then also have 1 2 3 4 5. Now we are in the middle, right? Also going up 1 2 3 4 5. 1 2 3 4 5. The player is in the middle. You guys understand?
So you have
Yeah.
to make the number of arguments, you have to make them an odd number in order for it to be at the center.
Not really. You would get marks even if they were not an odd number, but then as long as your algorithm in your head, it makes sense that if I get the total number of rows I divide by 2, I'm gonna be in the middle. Also the number of columns divided by 2, I'm gonna be in the middle. Then as long as you do that, it makes sense. And then it makes sense, and then you apply it, you get your full marks. You don't need to make your rows odd. But then the algorithm works according to your maths. You're gonna give it the maths, it's gonna apply it, and then it's gonna put your player in the middle.
Okay.
Are you following?
Yes, sir.
Yeah.
So that's how you put a player in the middle. Ngazimula, are you following also? So now let's look at let's go back to, I'm just gonna remove that player in the middle function. Let's look at scattering the map pieces, right? How do we scatter our map pieces? We scatter our map pieces by as long as we have a map piece, we're gonna try and get a random row and a random call, and then after we get a random row and a random call, we are gonna now check what's inside. What, like, let's say we get a random row, let's say we got this as a random row, we need to check what's here, because we cannot put a map piece if there's a tower or if there's another map piece. So we have to make sure that what is here is not a tower and it's not a map piece, right? We can use an if statement for that. But then if I was doing it with my hands, I can just see, I can just find a random row, and I said, nah, there's something here, let me just find something else. There's nothing here, I can put my map piece. All right, so let's get the feature that is inside that row. So feature, game world, AR world, and then intro, then call, right? It's gonna give us, so remember, this is gonna give us what's inside one cell. Are you guys following? In a random row and a random call,
Okay.
right? So now we need to check if feature is equals to a tower, right? We cannot do anything, right? So let's just do this to make our lives easier. We say if feature is not tower. So what we're saying is that whatever we found, if it's not tower,
Then
right,
place.
we can place. Yeah, definitely we can place. But also we need to check for two things. It must not be tower, and it must not also be a map piece. So if feature is not tower, and just, I don't know why I missed. And feature is not a map piece, because it cannot be a map piece as well, remember? So it cannot be a tower and it cannot be a map piece. So that's what they said here, right? They said the map pieces are initially hidden. Map pieces cannot be placed on top of each other or on charging towers, right? So it cannot be a tower, or let's use or it cannot be a map piece. So if feature is not tower or is not a map piece, then we're gonna place our map piece there. Anyone lost?
Sir,
Yeah?
isn't it supposed to be int row and int call since we didn't use the for loop?
RC, yeah, true. Supposed to be int row and then it's supposed to be int call. So I just wanna ask you guys something. Do you think this makes sense? Like, don't just look at it, think about it also.
Sir, can you please explain the if statement? I lost connection there for a little bit.
Okay. So the if statement, right? Do you see this part where it says map pieces cannot be placed on top of each other
Yes.
or on charging towers? Right?
Yes.
So we're basically getting a random row and a random call. After we get a random row and a random call, we get a feature, we get what's inside that random row and a random call. So if I go here, let's say I generated a random row and a random call, and then I came here, I would get back a tower. So that feature would be a tower, right? But then if I was here, it would be a tree, right? So
Yes.
we now have a feature by doing this. So after we have a feature, we are checking is the feature, if the feature is not a tower or a feature is not a map piece, we are gonna put a map piece. You guys get it?
Yes.
Yeah. I just want to ask something. Does this make sense? Does the if statement make sense if you think about it? Like the if statement. Do you know how all works?
It makes
Do you guys know how all
Yeah.
works?
yeah.
So
Isn't it that you
one of
it
them has
will-
to be true, right? So if one of them is true, that means the whole statement is true. All right. So now I doubt all would work here, because let's say our feature is a map piece. It's gonna come here. It says, is the feature is it not a tower? Yeah, it's not a tower. It's a map piece, right? So this statement will be true because we're using or. So we have to say and, because the feature cannot be a tower and it can also not be a map piece. Both must hold, right? You guys remember the ands and the ors.
Yeah.
Yeah, so it must be an and,
Yeah.
so that we cannot be a feature and it cannot be a map piece. So this would work if we use an and here, because we cannot put it on top of a a tower, and we cannot put it on top of a map piece. So if that is true, we're gonna put our map piece, and then are we done? Look at the code. Are we done?
Let's see. I
Sir,
don't see anything missing for me.
Are we done?
sir,
Yeah.
before you move on, can you go?
According to me, I think we no. Let's see. We haven't like placed them random. A random function, I think.
We need to place them in a random function.
Using no, never mind. We have already defined the random variable above.
What was the question for the other student?
So actually, you know, when you asked like, was there something that that we didn't understand with the code earlier on? I was having mic issues. Can you just go to how like we use like the libraries, which libraries do we use and stuff like that?
We'll do that after this.
Okay.
Yeah. So, do you guys think this code is done? Let me just zoom so that you guys have a look at it and you think about it for a moment. Just think about it for a moment. It's logic. It's basically logic. There's nothing complicated here. Nothing too advanced. Just tell me if it will work or not.
Okay. Do we need some like I don't know if like the code for now will place only one map piece. Don't we need something like that will loop through to like to place other map pieces?
So, line 64. Right? You were on the right track. So, guys, what's missing? This code will run forever. Like logically speaking, it will run forever. So let's say the user enters the map piece, 5 map pieces, and then we come to line 64. Is GameWorld.int map pieces greater than 0? Yes, it is. We're gonna generate a random row, random call. You check the feature. If it's not a tower, if it's not a map piece, we're gonna place that piece, and then we're gonna go again to the while loop. Is map pieces greater than 0? Yes, it is. It will always be greater than 0.
Or gonna the while will just loop until
So we need to find a way to decrement that value. So as long as we have placed something, we're gonna come here and say game world.int map pieces minus to decrement our map pieces so that they reduce every time. Remember when I said, I even did it with you guys here, I had 5, and as I was putting, the number was going down every time. Right? Every time the number was going down until I got to 0, and then I stopped because I no longer have map pieces. Okay. Alright, so let's run this and see if it works. Game world. Let's first start without map pieces. I did not really put map pieces. It's still fine. There are no map pieces here. There's just T and X as far as I can see. And then if I do this now, scatter map pieces in my game mode, and then we run the code again. Now we see map pieces. How many map pieces are gonna be there? 5. 1, 2, 3, 4, 5. And there's no map piece on top of a tower. All of them are in their own places. Right? If I want to increase the number of map pieces, let's say from 5 I want to go to 7, I'll just go to my set programs arguments, and then map pieces is the last one. It was 5. Let's make them 7 now, and then build again and run. We should now have 7 map pieces. So 1, 2, 3, 4, 5, 6, 7. There's no map piece on top of the charging towers. You can see each and every row still have a charging tower. You guys are following? Anyone who's confused, who's who's lost anything at all, just let me know. I'll give you
So-
guys a while to process this. Yeah.
So whenever we need to like whenever if we wanna display something, you need to call that function inside the main function.
So if you want to run a function, so for example,
Eh.
scatter place towers. If you don't call place towers, no, in here like so, where did we call place towers? We called place towers. Let me see, place towers. We called it inside the initialization. So if you don't call place towers and you pass your world, it'll never place towers automatically. It doesn't really know whether to do it automatically or not. Also here, the scatter map pieces, we can remove this as well and we just put it inside the initialization function because everything is part of the initialization. So we can go inside the initialization and then we say place towers. After we place towers, scatter map pieces, give it the game world. And it's gonna do the scatter map pieces for us. And then we also test our code by running it to see if there are indeed map pieces in our code, which they are here. Are you guys following? Nonkazimulo, are you still there?
Yes, I'm still here.
Are you lost? I feel like you're lost.
No.
Are you sure?
Yeah.
Okay. Okay. Now let's say now let me just keep it simple. But you guys, this is the logic. This is something that I can never really install in your brain. It comes with practice and thinking about how to solve the problem. Right? I had to solve this thing here using my hand and clicking and putting it. So but then in code it's basically the same thing. Just that you generate a random row, a random call, and then you check what's inside that random row and the call. If it's not a tower and it's not a map piece, put your map piece there, and then you decrement the map pieces so that at least this condition can stop running at some point. Do you understand? Alright, cool. So now we are done with this part here. The command line define map pieces are scattered randomly throughout the world area. Map pieces are initially hidden and do not appear. So that's what we need to account for right now. The map pieces, they are saying that they are hidden and do not appear. So what do you guys think? How would we do that? How would we hide the map pieces? It's logic. It's the same thing. Like it's logic, guys. I would say. Okay. Yeah.
Sir, I think you place where like there's a tree, you place the map pieces. I don't know.
Which is what we did here. That's exactly what we did here.
I'm not sure.
It's logic. Guys. It's like if I come here to my Excel and I say map pieces are hidden. Wherever there's 3, I must hide. What would I do? I would come here and make it white. Let me make it the color white. Now it's white, and then now it's white. You see, it's hidden. All of them are white. It doesn't mean that they are not there. They are there. There's still 3 there, but we can't see them because they are hidden, right? I'd make it the color white. I'd make it the color white. So think of it in that sense that if my map pieces are hidden, what I'm telling you guys here, it's basically how you think and how you solve computer science problems. Think about it. If something is hidden, how would I show that it's actually hidden? You can put a tree on top of it, right? It's hidden. But then now if you put a tree on top of it, how do we know that there was a map piece there where we put a tree? How do we know that there was a map piece? Is it difficult?
That's getting confusing.
Okay, which part is losing you? Which part confuses you? I feel like if I understand where you guys are really confused, then I can try to help you think in the right direction.
The part where they say it's hidden below a
Now,
tree.
is it like more of like, are we gonna like replace back wherever like there's a map piece back with a tree?
It's possible. Do you think it would work when you think about it?
I really don't know because we've already like replaced a tree with a map piece. So reversing that thing, I don't know how we might even do it.
Yeah. Anyone else? Just think about it. I'm also thinking. You see, I don't have like I don't really follow the memo. I'm using my own head. Like I'm trying to think, how would I do this and put it in code, right? How would I do? And trust me, for trying, you're gonna get something. So if you look at the memo has there's marks here for logical correctness. It's out of 5. Effective and efficiency of approach out of 5. Correct use of approach selection out of 5, and then correct output out of 5. You could get 15 here without doing the right thing. But as long as they see that, okay, what this person is trying to do, it's sort of like making sense. You could get 15 out of 20 here. Don't just leave it blank and say you don't know how to hide. Just try to think, how would I hide? How would I hide the trees? How would I hide the map pieces? You know? I'm just gonna give it like 2 minutes so that you guys think about it. How would you hide? You have a grid. Let me open this thing again. Maybe if I open this thing again, you will understand. So how do we hide something? So a hint would be in the display function.
So can you go to the display function? Time C. Sir.
Yeah?
Ash, I don't. I thought I was thinking that if like we did it like maybe like character, and then we say where like there's character tree, we say output character map. No, where there's character map piece, we say output character tree. But I don't know how we
Yeah.
do it.
That's one way of doing it. You could do that. You see, that's some logic that would make sense. So where there's the map piece, you just put a tree. When you are outputting, you don't come here. So guys, you don't come here. I don't come here now and I delete this value because I still want it to be there. As long as it might be hidden, I still want it to be here so that when I need it, I can access it, right? I just make it white. It doesn't really mean that it's gone. It's still there. But then when I'm displaying, this is white. So one way of doing it is what he said. We can come here, right? If this, so we say, if a feature is a map piece, we don't want to output that map piece. What do we want to do? We want to put a tree instead. It doesn't mean that the map piece will be gone. That means that wherever there's a map piece, we're just gonna output a tree. We're basically hiding. So let's just test to see if this works. So yeah, I'm just gonna say else. So if it's a map piece, we're gonna output a tree. Else, we're gonna output whatever it is. So see out a tree. I think it was X. We call them X, if I'm not mistaken. And then now let's run this. There we go. So we do have a map pieces here, but they are hidden. That's one way of hiding it. You did what you had to do. You did hide the map piece. The stars are no longer here. Right? You did hide them. So just to show you guys that we really did hide them. Instead of X, I'm just gonna put O. Just to show you that wherever there's a map piece, it's just gonna put O instead of a star. You see? So they are still here, but instead of a star, it just outputs O. So us, instead of putting a outputting the map piece, the star, we're just gonna put a tree just so that they are hidden. They appear to be hidden, but they are still there. You guys follow?
Makes sense.
Yeah. So they are still there, just that when we are outputting, we hide them. Okay, cool. That's one way of doing it. There's so many ways of doing it, but then this one also works. It works fine, right? So now let's see what we have covered. The map pieces are initially hidden and do not appear. The map pieces cannot be placed on top of each other or on charging towers, but can be hidden below a tree, which is what we did. We basically hide them below a tree. Alright, so now we're gonna come now and look at the drone. The drone starts in a random row in any one of the last two columns of the array. So now we're introducing something new, which is called a drone. Let me come here. And so our game world will have a drone, right? You guys agree? So a drone is also its own thing. It's also its own structure. It's gonna have its own rows. It's also gonna have its own calls. It's also gonna have its own battery charge level. So I can just say struct drone. Drone doesn't matter how I drew it, but then drone. The drone will have the row where it is, like the row is basically where's the drone in the map. It's also gonna have a call for where which row and which call is the drone, and then it's also gonna have int charge level, right? So int charge level, or just call it battery, int battery level. So that's the drone. The drone is also inside the game world, right? So we're also gonna come inside here, and then we're gonna say that we have a drone. Anyone who's lost? You can ask any question, as long, even if it's stupid, just ask, and then maybe you are lost. Maybe I can assist you. Anyone who's lost?
Why does it have a battery level? Also, where there by line 37 or it's 36, they're saying drone. I'm not quite sure why
Okay.
two of them.
So a drone is a structure, right? Like it's a struct, right?
Yes.
So if a drone is a struct, it means that it has things inside. It has rows, it has a row, and it has a column, and it has the battery level. You follow?
Oh, yes.
Yes. So all these collections, they all belong to a drone. That's why they are inside the drone structure.
Yes.
They are a drone. Basically, these are the properties of a drone. Let's look at our game world. Our game world has rows, it has calls, it has chants, it has map pieces. It also has the grid, right? Now,
Yes.
our drone has the row. Where's the drone in the thingy, in the grid? So if I have a drone here, let me just put D. Here's the drone. That drone, it's at this row and it's at this column. That's why it has a row and a column, and then it also has a battery. So let me just say drone has row, and then it has a column and it has a battery. So the battery, they said it starts at 10, and then the row can be anything between, as long as it's inside here. So let's work on this together. Row 1, 0, 1, 2. Right, column 0, 1, 2, 3. So row 2, column 3. Row 2, column 3 is where our drone is. Are you following?
Yes.
Yes. So that's why we did a drone on its own structure to put its own thing in its place, and then we put it inside the game world like this. You follow?
Mm.
Yeah. There was no need for me to do it this way. I could have also done something like this. Instead of having a drone structure, I could have even said here int drone row. So drone row, and then int drone call, and then also int battery level. I could have done this. It's allowed, but then now I see that these ones, they belong together. These ones can be grouped. These variables, they can be grouped, and then I group them outside, and then instead I just have a drone here like this. Are you guys fine? Anyone confused, lost?
Actually, what that means is it that we are now adding a drone with its structure to the game world.
Yeah, we're adding a drone. And what is a drone? A drone. We're adding a drone. Drone. And what is a drone? Drone. A drone is like something that has a row and a call and battery level.
Oh, okay.
Does it make sense?
Yeah.
Okay. Anyone lost? I'm just gonna pause a bit so that you guys digest this. Just think about it, like, you know, what I just did now. We just have another structure, and inside that inside our old structure, we put our drone structure in there. Anyone confused, lost? Oh, you guys are fine.
Yeah.
Okay, cool. All right. So now let's come back to our initialization function, because we're still busy with the initialization. So we placed towers, we scattered our map pieces, and now what are they saying? The drone starts in a random row in any one of the last two columns of the area. The drone flies over the trees and can occupy the same location as any other feature in the world. Okay, that one I understand. And then the drone starts with a battery charge level of 10 units, right? Okay, so from this, I'm gonna try and create another function, right? So I'm just creating functions so that I don't put everything in one place, so that you guys don't get confused. So I'm gonna call my function place drone, right, or initialize drone or place drone or whatever. But then that function, because we have the function that places the towers, we have the function that scatter the map pieces. So let's also have a function that places the drone. So place the drone. Right. You might realize that my code is a bit different from the memo, but then it achieves the same goal. I'm just basically putting everything in a function so that you guys understand when you are doing your test. So I'm gonna copy this. By the way, when are you guys writing?
Friday.
Oh, you still have time. Yeah, you still have time. You'll be fine. So now I'm gonna go to my function that I call place drone, and then I want you guys to help me place this drone, right? How would we place a drone? Let's go back to this. How would we place a drone here? They also did mention that your drone, it must be, so the starts in a random row, right? Highlight that in any one of the last two columns of the area. In any one of the last two columns of the area. Right? So last two columns of the area. What do you guys understand about this?
Isn't that it means like the drone can like only start maybe in reference to what I see on Excel now, like the drone can start at any place in the column G or H.
Absolutely. Yes. That's what it means. It means that your drone must be somewhere here. The last two columns. That's where the drone must be. And then random row, they mean like it can be anywhere in any So basically random row can be anywhere here, but as long as it's the last two columns. Are you guys following?
Yeah.
Anyone who's lost?
No.
Okay. So how do we achieve this?
Sir,
Yeah.
you already created drone as its own row and column, right? So in the column, in the row, you just say get rand zero, not zero, yeah, zero. I'm not sure about the row, but the column is like get rand int calls -2 because it's the last two rows. I'm not sure. Yeah.
Okay. Confidence is key, guys. You guys understand what I'm doing here?
Yeah.
I'm basically putting the row and the call of the drone. Nkazimulo, do you follow or you now lost?
No, I follow.
Okay. So I'm basically putting so I'm setting the drone, the row of the drone. Where's the drone? And I'm also finding the random call of the drone because we have to place it randomly. And then what do? I have to find the last two columns. How do I find the last two columns? So this column here is its number of columns -1.
Minus
This one is
1,
number of
this is
columns
minus
-2. So we're gonna start from number of columns -2, and then we're gonna end at number of columns -1. So game world dot int calls -2, and then game world dot int calls -1. Then we're gonna put a drone. Then that's actually we placed our drone. That's where our drone is, right? And then so placing drone is just these lines, and then let's also set the battery percentage of the drone. Game world dot drone dot in battery level, which is equals to 10. Right, so for this 10 I'm just gonna put it, you remember when we had -1, what we did, we just put it in the name constant. You guys remember what we did earlier on?
Yeah.
So yeah, I'm just gonna do the same for that. I'm just gonna come here and say const int, and then let's say let's call it battery level. Battery level of 10. So now here I'm gonna come and say it's gonna be battery level, and then I'm gonna place my drone. So now I'm gonna come to my initialization function, and then I'm gonna call. So I place the towers, I scatter the map pieces. Now what do? I place my drone. Game world, bypassing the game world. That function will place my drone, right? Okay, cool. So now that we've placed the drone, they're saying that the drone starts in a random row in any of the last two columns of the area. The drone, the right hand side of the area. Okay, the drone flies over the trees and can occupy the same location as any other feature in the world. And then the drone starts with a battery level of 10, which is what we have. So we do have the battery level of 10. And then now what we need to do is we need to display the drone in our map piece, right? Any ideas how we're gonna display the drone? Any ideas? How are we gonna display the drone? It's not a trick question, guys. It's a basic question. It's simple. How would
Sir,
yeah?
if you say int feature, you introduce each statement, right? And then you say if feature is equal to drone, you output, and then that's it.
Okay.
That's all I can do.
Close enough. So it's not like that, right? Because the drone is never really inside the the grid. We didn't really put the drone, like we didn't do something like this. We didn't do something
Okay.
like this where we said drone, right? We never
Okay.
did it, right?
Okay.
We only have the rows and the calls for the drone. So what we are gonna do, it's basically we're gonna have to find a symbol for the drone, right? We have to find the character that will represent our drone, and then we are gonna use that character for our drone. So the drone is different from these other features because these features are actually put inside like this, but the drone is not put inside like this. We just have the rows and the calls for the drone, right? So what we can do, we can define a constant for the drone symbol, right? So something like this, const char drone is equals to, let's say, add symbol for the drone. Let's say this is our drone, and then after we have this, we go to our display function. In our display function, we now check, we need to check if R and C is equals to the drone's R and C. Do you guys understand? So what we are gonna do, I know it's getting confusing, but just bear with me here. Remember that a drone is not really inside, right? It's just that we have the rows and the calls for where the drone is. So since we just have the rows and the calls for where the drone is, like, right, we don't really have like the drone inside our grid. We just have inside our grid, we have trees, we have map pieces, we have towers. We don't really have the drone inside, right? We just have the coordinates for where the drone is. So if this is 2 and 3, we're gonna come to row 2, 0, 1, 2. We're gonna go to column 3, 0, 1, 2, 3. Here we're gonna say there's a drone here, but there's not really a drone. It's not really there. We're not gonna replace this value and say D. No, we just have the coordinates of the drone. So what we are gonna do, we're gonna come where we are displaying, right? Instead of looking for a feature, we're not gonna look for a feature. We're gonna compare the row and the column if they match the drone's row and column. How do we do that? Just say here, if R is equals to game world dot drone dot int row, right? And
Okay.
C is equals to game world dot drone dot int com. Then we're gonna see out a drone, right? So we're gonna see out a drone. So see out a drone, and then now we're just gonna say else if there's no drone. If there's no drone, then we're gonna do what we do normally. We're gonna check what it is, and then we're gonna output our features. So guys, you see, logic is the part that is difficult, right? But then if you understand the basic, if you can explain it to a child, what I'm explaining to you guys, if you can explain it to a friend or you explain it to someone else when you are doing it, it will end up making sense, right? So now are we gonna have our drone placed? I'm not sure. Let's just try to see if our drone will be placed. Yeah, we do have our drone placed. Here's our drone here.
Sir,
Yeah.
wouldn't it have been easier if you just included it with the other features?
No, it wouldn't have been easier. You know why?
Uh-huh.
Because our drone is not really inside the world, if you think about it.
Oh, it's flying over.
Yeah, it's not inside, it's just flying over. So we only have the
Okay.
rows and the calls for the drone. It's not really inside. But then the rest of the things, let me show you guys again once more. Let's go through this once more. The trees are inside. Do you guys see this? The tree is inside,
Yeah.
right?
Yeah.
We did put the trees first. The towers are inside. We did put the towers as well. The map pieces are inside. The drone is not inside. we just know that it's somewhere around here. But then how do we find? How do we know where? How do we display the drone? By its coordinates, its rows and its row and its core, right? And then one last thing that I would do in the display function, I would just display the battery level of the drone if you wanted, right? So drone battery level, and then you just do your let me just do it down here so that you see. Just say game world, because the drone is inside the game world, dot drone dot battery level, and then end line. Now when we refresh and then we run it, it's messed up, right? You guys agree it's messed up like this? We don't want it like this, right? So if you see something like this, just know that, okay, every time we are looping through the rows, we are displaying the battery level, which is not good. Let's just take everything outside the rows, outside the rows. When we are done with the rows as well, now we want to output everything. Yeah, when we are done. So let's try again. Yeah, then there we have our drone battery level of 10. Any questions? It's getting heavy now.
Yeah.
Yeah, it's logic, guys. There's no perfect way of doing it. To be honest with you, logic is just like something like practice. You need to practice logic. Like if they talk about diagonals, how would I move diagonally? How would I move up? How would I move down? You know, in PR minus, in PC plus. It's all logic. So now we are done with our initialization. How many marks do you think we're gonna get here? Just asking. In our initialization, how many marks do you think we were gonna get?
Maybe around 12.
Around. Okay, let's say I'm asking in a sense of, if this was out of 20, how much would we get out of 20? Like what? Like let me see how many people. Okay, let me say 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say this was out of 8 marks. How many marks would we get? It's not rocket science, guys. It's like an easy question. How many marks? Okay, let me just show you how I would mark this if I was a marker. I would come here. I would say the size of the environment, the chance of the charging towers getting destroyed, and the number of map pieces are given as command line arguments. So let's see. They are given as command line arguments. I would give you your marks, right? And then I would come here to the second bullet. The world is filled in the following order. Entities cannot occupy the same position in the world order except where stated otherwise. Every square in the world contains trees. And then I would go to your initialize, and then allocation there. Every square contains trees. I would give you your mark there. Each row in the world area has a charging tower located in a random column. Charging towers override any trees in that location. So I would come to charging towers, place towers there in a random column, and you'd get your marks. The command line defined map pieces are scattered randomly throughout the world area. Map pieces are initially hidden and do not appear. Map pieces cannot be placed on top of each other or charging towers, but can be hidden below a tree. Are they hidden? I would first check, are they placed? Okay, here are the map pieces, they are there. Are they hidden? I go here, and then I say, okay, they are hidden, right? The student, what they did, they said if there's a map piece, they're just gonna hide it, put an X, like you get your marks there. The drone starts in a random row in any one of the last 2 columns of the area. Okay, I come, I say, where did you place the drone? Here's where you place the drone, in a random row, and then the last 2 columns, right? You get your marks. and then the drone flies over the trees and can occupy the same location as any other feature in the world. Okay, fine, I get that. And then the drone starts with a battery charge level of 10 units, right? So just do the same thing. 10 battery level, and then what is the battery level? It's 10, and then if I check the program, it compiles, and yes, everything. Yeah, I got my 10 marks or your full marks for initialization. Applying logic is the trickiest thing that you guys need to practice. You have 5 days to get this right. If every day you spend 30 minutes, you look at the logic, you try to memorize it, you try to do it on your own, you're gonna get it right. It just comes through with practice. With practice, you're gonna get it right. You're not gonna struggle, especially when you're gonna be writing. Moving. Now we come to the moving part. We are done with initialization. Took us almost the whole day doing initialization because I wanted you guys to understand. I didn't just want to give you guys the answers. I wanted you guys to understand so that you can be able to do it on your own. So, do you guys think you can be able to do initialization on your own? Or it needs practice?
Practice.
Practice, right? Yeah. Practice. You'll be fine. Anyone who's lost? We're gonna take like a 2-minute break and then do the moving. But also with the moving, it's gonna be the same thing. It's gonna be I'm gonna be applying the same logic of if I wanna move, what do I do to the player and so on. So any questions so far?
No question from my side.
Okay. Kazumulo?
Yeah.
Any questions?
No questions.
Okay. To me?
I'm good.
Okay. Are you guys ready to proceed?
Yeah, you can proceed.
Okay, cool. Right. Let's look at moving. Moving, it's obviously moving the player around the grid, right? So the player may move in any direction, including any diagonal direction. So once you get to the moving part, right, I want you guys to do your menu system, right? This is the part where we're gonna be doing the menu system. So once you are done with the initialization, please try and do the menu system, right? How do we do? Everyone knows what the menu system is, right? It's basically that prompt: input something, and then you input something, and then it does something to the world, right?
Yeah.
So the menu system is quite simple, straightforward. Memorize it as well. It's simple and it's nothing hectic. You don't need to stress yourself about the menu system. You just need to memorize it and code it quickly. So while this continue, we're gonna do while loop. Do while BLN continue. Also remember, do not deallocate inside the while loop because you're gonna crash the program. You must deallocate when you are done. You guys understand?
Yeah.
Yes,
So deallocate when you're done. So the menu system has the following syntax. It displays the world. It prompts the user for an input, and then it does something, and then it repeats, right? So we're gonna use something like, okay, let's display the world, and then after we display the world, we want to initialize option. This is, guys, don't worry about this. It's straightforward. You just need to write it as it is, and then you'll get your full marks. Option, and then we're gonna switch on that option. Switch, and then case, and then we're gonna have cases inside the switch. So what I forgot was to prompt the user for something. So prompt the user, say out, please enter option, and then you can further say that please enter option, and then you say that okay, let me not do it in a straight line, so let me just say please enter option, then you just say that A is a, let me just write this nice. So say A is to move left, W is to move up, and then D is to move right, and then S is to move down, and then let's say we also have other things such as, so how you guys are gonna do the C out, it's up to you. There's no perfect way of doing it, you just need to make sure that it makes sense. So Q, it's gonna move diagonally, right? Because they say that it can move in any direction, including diagonal direction. So Q, I think I should have used, instead of left right, I should have just said west, west, A for west, and then up for north, and then B for east, and then S for south, and then Q for northwest, I think. Yeah, northwest. Let's just do it so that we can finish quicker. E for northeast, and then C for southeast, and then Z for southwest. Right? So the user will have to input an option. So let me just say end line. And then, so we forgot to include also exit. So if the user wants to exit the program, can they exit the program? Yeah. Let's say X for exit. No, yeah, X for exit. And then end line. So now you have your menu. It's gonna show. It's gonna say this to the user, and then the user will input something, and then now you're gonna come here and you're gonna check all those options. You're gonna check for A, and then also gonna check for everything else. So A. So let me do this. Check for A. Copy this. Paste it here. Check for W, check for D. So 1, 2, 3, 4. But this was, I think this was an exam, eh? Yeah, it was an exam. So a semester test 2 might be at least better. You won't have to put so many things. So guys, once you practice this exam, you'll be fine. So okay, cool. A, we're gonna have A, W, D, S, right? So A, W, D, S. Then you're gonna have Q, E, C, and then Z. You have Q, E, C, and then Z. Then you're also gonna have X. So X would say to the user, see out, well, you just say something like exiting the game, and then you're done. So BLN, this was the one that will change the BLN continue to false, because it's the one that will stop the game. So this one stops the game. And then there's also default. If the user enters something that is not inside our defined scope, you just say cout invalid input. And then you can also just show the user what they've entered. And then so please try again. Please try again. So the see out, guys, you're gonna decide how you want it to look like. It's up to you. And then system pause. Do you guys know system pause? I'll explain. I'll show you why we system pause. But we system pause so that it pauses, and then we can press any key to continue. So also here we're gonna system pause. We're gonna pause where? Pause here as well. Pause. So the menu, so guys, the menu, memorize it. It's simple. Memorize the menu. You go right, everything that I'm doing here, it's gonna come exactly like this. There's no logic here. So most of the code there's no logic that needs to be applied, but then most of the things as well, some of the things needs logic. But you can probably pass without logic, because logic is out of 20 marks. You can pass without logic, but you're not gonna get a distinction. So we want to make sure that you get a distinction and then you apply your logic. But then even if you don't know the logic, try to write something, try to code something that at least doesn't break your program. You will definitely get marks here. All right, so for moving the player, we're gonna need a function for moving the player, but let's just run to see what we have so far. All right, so this is what we have so far. Obviously it's not fancy, but then it just says please enter option. Let me just put these ones also in the same in the own line. Okay, end line, and then also for the option part, end line. Any questions with regards to the menu?
Sir,
Yeah.
what's the difference between system clear and system pause?
Okay, so clears the screen, pause pauses the program. So I'll show you what clear does. So if I run this now, it's print. You see, it's printing again for the second time. If I run, it's gonna keep on printing, but then we don't want it to be like that. We want it to clear and print a new thing. Clear, print a new thing, right? So I'm gonna exit the game. That you see, this was system pause. Press any key to continue, right? So if I restart again, and then I say here X immediately, exiting the game, it gives me an opportunity to press any key to continue so that I can have a look at what happened, right? And then I press any key and then it exits. Done. So system.clear, like I said, we want it to clear the screen every time. So we can just come here and say system and then CLS to clear the screen. So compile, run. So now when I do menu, you see now it clears the screen and rewrites the same thing again. You see that it's no longer printing on top of everything or going down. It clears the screen and then draws, clears the screen, draws, clears the screen, draws. And exit the game. So now let's go to implement the move function, right? Obviously here we want to come and do something like move player. So how we're gonna move the player? We're gonna come to our header file. We say, okay, we need a function to move the player. So I'm just gonna do it after the display. So void move player. What does the move player? What should move player return? Nothing. I don't wanna see anything after I move the player. I just wanna move the player and that's it. So I'm gonna move player, and then after I move player, I'm gonna give it the world. And then I'm also gonna give it the option, because I want to move the player based on the option that will be passed. So I'm just gonna come to my CPP file and implement that. After display, where's display? Here's display. After display, I'm gonna move my player. So how do I move the player? I look at what option was passed in, and then I move the player accordingly, right? Do you guys have any ideas how we're gonna move the player up?
Is it plus plus?
Sorry, what's that?
Minus.
You put the two pluses together to move it up.
Okay, but where exactly? What does that mean? Let me go back to the grid. I want you to explain to me in terms of a grid. So let me make it red. Okay, red is too much. Let me make it gray. So let's say this is my drone, right? I want to move it up. Apply logic for me.
Would you?
Guys.
Isn't it?
Sir,
Isn't it that we'll find what is the position of like the grid? Let's say it's 5, then minus 1
Okay, close.
to move it up.
Close. Anyone else?
sir, I think we have to introduce no, not introduce, initialize the column and row where the player is, um, in this case, and then we introduce a switch case whereby like um we if the player is chosen to go up, we maybe increment or decrement the row and the column according to which movement. That's what I think.
Definitely. Yeah, so that's absolutely correct. I just want to show you guys the simplest form because, like, obviously everything has everything as its the basic fundamentals of it, right? So what I'm gonna do this. I want you guys to pay attention, right? I'm gonna do this only.
Yeah.
So I'm gonna do this, and then that's all that I'm gonna do. What is gonna happen when I do this? It's that let's just run it and see. So now, let me just post. Let me just comment out the menu for now. I'm just gonna find Notepad++ to put it. Notepad to put it there. So I'm just gonna take the menu. Actually, let me put it in a new file right here. No, don't save. So I'm gonna remove the entire menu, and then I'm gonna come back to main. So now I'm gonna say game world, and then I'm gonna display my world. So sometimes you don't have to complicate everything in order to understand the logic and to fully grasp what's going on. You just need to deal with the most basic thing. So here's my player here, right? So what I want to do, I want to move it up. So let me just move the player up, move player, and then I'm gonna pass in the game world, and then don't worry about the character for now. Then I'm gonna display the game world again, right? So this is the most basic fundamentals. All I did on my move player function is this row minus for my draw. So when I run this, why is it complaining? Empty character. Let me just make it null. So let me run this. Okay, I want you guys to see something, right? The player was here. Now the player is here. Do you guys see that?
Yeah.
The most it's basic. It's the most simplest thing, right? It's you don't overthink it at first, because if you overthink it at first, you won't be able to handle the problem. So now we know how to move the player up. Obviously, if we want to move the player down, what I was gonna do, I was gonna come here and say plus instead of up, right? And then the same will apply to the call. If I do call, you can imagine that it's either gonna come this side or it's gonna come that side. You guys follow?
Okay.
So this is the most basic fundamental way of moving a player. The most fundamental that you guys need to understand. You need to manipulate the player rows and player calls in order to move the player. So let me just erase everything and then put the menu back. And now let's go and actually try to apply logic, right? So if we want to move our player, we're gonna do something like switch, right? And then option, and then we are gonna say case. We're gonna apply the same case as in the main until Z. So all these cases are gonna apply. Paste. Then so is it fair if I move the player in one direction, and as a homework you guys must be able to move the player in all the directions? Is it fair?
Is it fair to do what?
So
What?
you guys believe that I can move the player in any direction, right? Who doesn't believe
Yeah.
that I can move the player in any direction? But like, yeah, you guys believe that I can move the player in any direction. Is it fair if I move the player up only, and then as a homework you guys are you're gonna move the player around, also including the diagonals, using the maths and the logic?
Uh,
I don't think.
Or
Okay.
you want me to move the
Could be
player
much of a
everywhere?
problem.
You don't know. You're not sure yet.
For me, I think I can do it.
Nkazi, can you?
I think I can try.
Okay, cool. Okay, say it with me then. Let's move the player up. Game world.
Good.
Dot. So one person speaks the next word, and then the next person speaks the next word, and then just like that. So when I move the player up, game world dot.
Drone.
Okay, someone else dot.
Dot int call or is it int row?
Which one is which? In rows or in calls?
You're moving it up.
Yes.
It's int call.
No, it's rows. Okay. In rows.
And
And then and then minus minus, right?
then,
So
yeah.
so Nkazi, calls and rows, right? These are calls. These are rows. These are rows, not calls. These are rows,
Yes.
right? These are calls.
Oh, okay.
So if I say int rows minus minus, if I minus rows, I'm going to the row above me. And then if I say
Oh,
call minus minus, I'm going to the previous call. But then if I say call plus plus, I'm going to the next call. Okay?
That's a
okay.
So yeah, let's do it like this. The drone. Well, now we're moving it to the W. It's up. Okay, W is up. Okay, so A was not up. I don't know why I was confused, but A was supposed to move up. No, A was supposed to move to the left, so it's in call minus minus, and then W is supposed to move up. It's in row minus minus, and then D was supposed to move it. We're supposed to move it to the right, plus plus. The more you guys practice, it's gonna become easier when it comes to dealing with int rows minus minus, int rows plus plus, and these are basically key. If you can write this down on paper and then you say this is the radius, you'll be fine. So and then for south.
Sorry, sir.
Sorry, what's that?
Sir.
Yeah.
Yeah, sorry to disturb. I wanted to ask, you said int row minus minus, you're moving up,
Up, yes.
and then int row column minus minus, you're moving to the previous column.
Yeah, like
Okay.
your left, yeah. So for Q,
Okay.
E, C, and Z, and everything else, I'm gonna explain to you guys. I just want to show you something now. So there's a chance that we might get out of, we might run out of the worlds, right? So if I say minus minus, if I keep on going to the minus minus, if you look at this Excel, if I go to the previous one, I go to the previous one, I'll end up getting to column 0, and then if I try to move, it's gonna move into an invalid space, and the program will crash. I'm gonna demonstrate that to you guys now. So let me just build this and run it. So here's my player, right? So if I do A, no, it's not gonna work now because I didn't really call the functions here at main. So at main, you must call the function move player, and you must give it the world, and you must give it the option. Give it the option as well. So you're gonna do the same for everything. Do the same for everything else, and then now it can actually move a player. I'm hoping, fingers crossed. So now let's say A. Okay, the player is moving, right? But if I keep on moving, what's gonna happen is that it's gonna crash. Let's move again. Okay, it's gone. It's out of the world, right? It's the player is no longer here. It's no longer visible. So we must not allow the player to go outside, right? It should normally crash the program because there's no space there. Let me just try to put it back. It's back now. It can go up and can go down, but then now it's lost. So we don't want to make sure that our player doesn't really get lost. I want to make sure that the player always stays in the world. So if I go 1, 2, 3 up, which is if I want to go up 3 times, I'm just going to say www. It's going to go up 3 times, 1, 2, 3, and then I go to the left, 1, 2, 3, 4, 5, and then so 5. So let's say 1, 2, 3, 4, 5, and then I want to go down 1, 2, 3, 4. I want to put the player somewhere here, so I'm just gonna guess that it's gonna go there. 1, 2, 3, 4. 1, 2, 3, 4. Hopefully it does get there. Let's see. Yeah, it got sent there where I wanted it to get. So it does move. The player does move, but then we want to make sure that the player doesn't go out of the grid, because the move function, they did say here that the player may move in any direction, including any diagonal direction, which is, so we haven't done the diagonal direction. Can you guys imagine how we would do the diagonal direction? Diagonal basically means that we want to move from here to here. Can you guys imagine how that can be achieved?
Yeah,
Right.
it's more of like in the
Let's
movement you include.
Yeah, definitely. Let's test Nkazi on this one. Nkazi, how would we move the player here?
I think that you need to put. You see how for going up and down,
Yeah.
you are only putting those restrictions for .col plus plus or .row minus minus.
Mhm.
So moving it there, you would need both of them. I
Okay.
think.
Definitely. So give me the code. I want to move this gray area. I want to move it here. What would I do?
Would you say game world dot drone dot intro
Mhm.
minus minus
Yes.
minus minus,
Yes.
and then game world dot drone dot int column also minus minus.
Yes. So yeah, mathematically it makes sense. If I go minus, so I'm gonna go to this, and I'm also gonna go to this row. Where they overlap, it's where the new player will be. So you're gonna apply the same thing for E. Just apply it with you guys, but then this code is gonna change soon. I'm gonna show you why it's gonna change, and then I'm gonna apply everything else for whatever is here, and then also here. All right, so okay, cool. And then for Q, this is fine. For E, we're gonna subtract the rows only, we're gonna add the columns. C, we're gonna add the rows, we're gonna add the columns. And then Z, we're gonna add the rows, but we're gonna subtract the columns, right? So plus plus. So you test your project. Is it still fine? Just zoom in. Let's say Q, we expect to see it here. It did go there. Then let's say E, we expect to see it there. E, it did go. So yeah, it's fine. I'm assuming the rest also works. Let's say X, exit. So now remember that they did mention here that the player may not move outside the game area, right? So the way in which we're going to achieve this is that we're going to store we're going to first store the drone where the drone is temporarily, right? So we're going to say int temp row. You can say temp row, and then we should just say or we don't even need to say temp row. We can just say int row is equals to dot drone dot int row, and then we want to say int call is equals to game world dot drone dot int call, right? So now we want to make sure that we move the player only if it's a valid move. If it's not a valid move, we're not gonna move. I'm gonna show you how we're gonna validate the valid move. But we need like the valid move function. So valid move function, also do this one, and then same applies here and here. So the valid move function is also something that you must memorize, it's straightforward. It just says that is the move that I'm gonna make, is it gonna be outside the world or is it gonna be inside the world? So what should the isValid move function return? Anyone can guess?
So can you repeat the question?
So the isValid move function, what should it return?
Yeah. It should return the position where the player is in terms of like ball and column.
Let's see.
Okay, no. Someone else?
I don't think it must like display anything.
No. Nkazamula, what do you think the isValid move function must return?
It should return an
Okay.
integer to see where it is.
So it should return a boolean, right? Because we want to check if the move that we're gonna make is valid or not. It's either true or false. Is this a valid move, yes or no? Right? And then we're gonna give it the row. We're also gonna give it the top. And then also the world, because it's gonna be moving inside the world. Game mode. So yeah, now you guys are gonna get this. You need practice, but the code that I'm gonna provide with you now, this is basically the most important code that you need in order to obviously pass your semester test. So the isValid move function, I'm gonna have to define. So where did I put it? I put it under display. So I'm just gonna go to display. Under display, I'm gonna say okay. Let me define the isValid move function. So if you give me a row and a call and you're asking me, is this a valid move? How will I confirm that it's a valid move? Pretty simple. I just need to know if that row is greater than 0, first of all. It's greater than or equals to 0. So if you look at this thing, it must be greater than or equals to 0 because this is row 0. And it must be less than or equals to the total number of rows minus 1. So that's how we validate if something is valid or not. So there's also another function called is in range, right? So bool is in range. So the bool is in range function, basically it takes in two things, right? So bool is in range. It just checks to see if the given value is in range. Is in range. So game one. But let me not add the is in range now. For now, let's just work with the isValid move first. So the isValid move want the row. So if int row is greater than or equals to 0 and int row is less than game world dot int rows, then we know that we are still in the world, right? It has to be in between.
Oh.
Alright, it has to be in between. Because we want the row to be inside the world. And int call, same applies to int call. Int call, the one that we are giving me, is greater than or equals to 0. And int call is less than game world dot int calls. Then we know that okay, we are returning true. This is also a function that you can just memorize. There's nothing hectic. Else we return false because we know that okay, it's not a valid move. So now if we are gonna move, so we're just gonna do our moves first. When we are done with our moves, so we're gonna get the row and the call, and then we're gonna apply our movement. And then when we're done, we see, which we try to check is if is valid move, and then we say int row. First of all, we pass in the game world, and then we say int row, and then int call. Then we move the player. Else we don't do anything. So game world dot drone dot int row is equal to int row, and then game world dot drone dot int call is equals to int call. So we're only gonna move if it's a valid move. If it's not a valid move, we're not gonna move. So let's just try to see if our code works. So now let's just keep on going west, west. Now it's no longer going. Let's go up. Now it's no longer going. Let's go down. It no longer goes down. Let's go right. No longer goes. You guys see? So it can only be inside the world. It cannot move if it's not gonna be inside the world. Right?
Yeah,
So the player
okay.
may move over. So yeah, did anyone have any question?
Sir,
Yeah.
can you go back to the
No
can
question
you go
from my
back to the
side.
is valid move?
Yeah.
Yeah. The what do they call it? The Boolean operator and. What if you replace it with a or? What will happen?
So logically speaking, right?
Mm-hmm.
Uh, if you think about it, it can either work. So remember how and this must be true and this must be true. So if you say or, one of these has to be true.
Yeah.
So what's gonna happen is this. Let's test it out. Let's keep on going. The player is gone because one of them are true. So if one of them are true, it's gonna return true. So we want both of them to be true, not just one.
Okay.
So it does, yeah. So this statement will never ever satisfy what our point if we do it like with an or. We need it. We need both. We need the player to be inside in the rows and to be also inside in the calls. Because what you are basically doing, you're basically saying that the player here, it's either it's inside the rows or inside the columns, right?
Oh,
Yeah, not
okay.
both. So it has to be both so that it's both.
Both.
Like yeah.
Okay, okay.
Has to be
Now I get
both.
it because I thought that logically, since like for a statement to be true in an or statement, right? One of them has to be true. But in this case, both of them are true. So I thought if it was or, it wouldn't really make that much of a difference.
Definitely.
But in this case, I see it does.
Yeah, definitely. So yeah, with practice, you're gonna get there. Okay, cool. So now we are done with that one. It works fine. The player moves, but then there's something that they mentioned that every time the player moves, we are losing a point. But then we're gonna cover that. So the player may not move outside the game area. We covered this part. The player may move over any square in the world area. Okay, cool. We covered this part. The player may choose to initiate a scan, right? Scanning an area. Scanning an area. I think they meant to say scanning an area reveals the features hidden under the trees. These features may be empty or contain a previously hidden piece. Scanning an area is similar to removing the trees from the scanning range, right? So now I'm sure you guys are like, nah, now it's chai now.
I were like that long time ago.
Guys,
Our minds are no longer here, yo.
it's a long,
Minds are no longer here.
Yeah.
it's a lot. Okay, cool. Yeah, we should have resumed tomorrow actually, but anyways, it's fine. Let's just try to complete this part of moving and then updating. So scanning basically, we're just gonna find the player. So if I go back to Excel, we find the player, and then we're gonna remove here around the player, also including the player. So we're gonna remove everything around. So the radius. So let me just draw out what a radius is for the player. So the radius is basically what's around you, what surrounds you. You guys get it? So that's the radius for the player. Yeah. So yeah, we're gonna scan, guys. Scanning, it removes certain things at the like where the player is, and I'm sure it removes the trees and then it leaves everything else behind. Okay, so um, I'm sure no one has any ideas right now. It's like, dang, what's going on? Okay, but this was exam, guys. I understand. This was like an exam, so it was exam paper A, 2022. I'm not surprised. Let's see the next one. Besides the scanning, moving the drone over to a charging station recharges the drone. The one is easy. Moving the drone over a map piece does not automatically collect the map piece. Instead, the player must specifically choose to collect the map piece. Doing activities with the drone uses up the battery charge. The following describes the battery charge. Okay, so what do you guys want? Do you guys want me to continue? Because since you guys are saying you're tired and everything, what do you guys think we should do? Do you guys want to go and try this out on your own, and when you struggle you can just maybe consult and then I give you the code, or I write the code down and just send it to you, or what do you guys suggest? Cause
I think we are almost finished.
okay,
We
so
can
you,
just finish the paper.
are you sure?
Yeah.
Okay, all right, cool. Let's go. Let's proceed then.
No problem.
So you may move over any square in the world area. You may choose to initiate a scan. So initiating a scan basically removes what's in the radius with the player. So let's see now how we would do that, right? If we scan, we're gonna have a scan function. Let's have a scan function. But before we have the scan function, let's also have the scan option, because we want to be able to scan. So I'm gonna come here, I'm gonna add a scan. So let's scan using P for scanning, and then this is gonna be for scanning. So we're gonna come to our move player function, and then we're gonna add that P for scanning. Let me see where it was. For P for scanning, right? So this will scan. Okay, cool. So if this will scan, what does that mean? It means that I want to scan. So I want to have a function that will scan. How will the scan function work? We don't know as yet. We're just gonna think about it as we do. Yo, this exam was hard, guys. I'm not gonna lie. It was way too hard. So if I wanna scan, I'm gonna come and do something like void scan, and then I need the world, obviously, because I can't just scan, randomly. I need the world to scan, and then say game world, right? And then I'm gonna implement my function. It's under move player, so I'm gonna go under move player. I'm gonna say scan implementation, right? So scan implementation requires the rows of the player and also the rows of the just the rows of the player, like rows and calls of the player. So let's just get the rows and calls of the player. So we're gonna get the rows and calls of the player because we want to know where the player is. Int row game world dot drone dot row, and then int call game world dot drone dot int call. So to scan, like I said, I mentioned to you guys, it's basically this going through this small world now. It's now gonna be a small world. So we're gonna start here, we're gonna loop through until here, go to the second one, loop through, go to the third one, loop through, removing what's currently there. Okay, cool. So let's loop through now for int r is equals to int row, which is the player row, -1. R is less than int row, then r plus plus. Same will apply for C. equals to int call -1. C is less than int call +1. Even here was supposed to be +1, and then +1 because we are starting here -1 until +1, then minus also for rows -1 until +1. Don't get confused. If you get lost, I'm here, C++,
The previous
then you want to
one.
scan, right? So to scan is basically we're removing what's there. So just say game world dot AR world and then RC is equals to empty,
Or
right? So it's gonna remove everything, but then I wanna see it's gonna remove the trees, but then it's not gonna remove the map piece. So scanning in the area reveals the features hidden under the trees. These features may be empty or contains previously hidden map. Scanning an area is similarly to removing the trees from the scanning range. So now let's come and change and get empty. We also need a symbol for empty. Empty, right? So we're gonna have empty. So now after we scan, we're gonna first check if it's a tree, we remove it. If it's not a tree, we don't remove it. So I'm gonna come here and say int feature to get what's there, and then if feature is a tree, we remove it, else we do nothing. As equals to empty. So this is us removing a tree. So let's try to scan, and you guys are gonna see what they mean by scan. So I'm gonna press what to scan, P for scan. So let's run it. Okay. Option. Wait. Yeah. Also, it needs to be a valid move. So before I scan, it needs to be a valid move. So if it's a valid move, I'm gonna scan. So this is where the logic gets really confusing, guys. I'm not gonna lie. We are already far now. Let's just try to continue. So if it's a valid move, we are gonna come and remove it. Okay, something is wrong. I have a lot of T's now. I don't know why. I have a lot of T's. So let's do this. Oh yeah, we need, remember I added empty? We also need something for empty. Let's just make it an empty space. So the reason why we were getting T's was because now empty was X and T was 3. So everything was messed up. So let's try again. Yeah, everything is back to normal now. So let's go up, and then let's try to scan. S for scanning, right? No, P. You see, it removed these things here because there were trees, right? I'm just gonna try to scan until I find a there's something also missing that I need to fix. Just remove everything. Okay, I'm not finding any map pieces. Let me try. I'm removing almost everything and I'm not finding any map pieces. So probably something wrong with the logic. We're gonna fix that together. Oh yeah. So it is finding map pieces, but the thing is it's not really showing them because they are trees, but it is trying to remove, you see. So yeah, I'm gonna say it's working fine. We just need to refine it so that it remains everywhere. Are you guys following? Are you still there? Any
Yes, we're
questions?
still here.
Any questions?
Okay, I just have a question, but not related to what you just did. You see at the beginning when you put in the arguments,
Yeah.
would those still be the same with the cmd.text? Because I don't use code blocks. I normally use VPL.
Why don't you use code blocks?
It's this.
The arguments that you put in at the beginning, remember you put 10, 10,
Yeah.
and other numbers. Would those arguments still be the same when I put them in the cmd.text?
Yes.
Yeah.
Yes, I
CMD.text. CMD. You mean this?
No,
Yes, the one.
she means
I'm lost. Yeah. What? Which one is that one?
So I don't normally use code blocks, ne?
Yeah.
I normally use VPL. So on VPL, you can't put in arguments the way that you put them here on code blocks. They told us to create a cmd.text.
Wait. What's VPL?
No.
Is it? Are you also doing it at UJ?
No. It's just coding on Martin
On a
Exit
VPL.
Cloud.
You prefer VPL.
Yes.
Why? Let me say what VPL is.
It's the
it works out
Exit.
the same.
Or it works out the same way.
I'm also using VPL.
Oh, okay. C++. Can you please assist her in terms of passing arguments?
Okay.
Is
It's
it-
like, isn't it that she's asking about what's this? Is it gonna be the same to put those arguments in VPL? So like in VPL, we create something called like a text file in a file for a text file where like we put the command lines and it runs with those command lines that we put in the text file. So it
Yeah.
works out the same. It's fine.
Oh, yeah. I think it's gonna work out the same. I'm not familiar with VPL, so but
Oh,
I'm
I
assuming
think
it will work out the same way. You can also double check and test right before you go and write, and you just to see if you get the right things. Okay.
Okay.
Okay, cool. Yeah, I'm sorry, I don't know VPL. So yeah, it seems like it is removing, but it's only removing at the top part. So just trying to figure out why is that? Why is it only removing at the top part? Okay, well, why is it only removing at the top part? I would think it's because of this. It's valid move. Let me just say it's missed. Okay, let me just not check anything. Let me not check if it's valid move at all. And then I'm just gonna run it again. So P. Okay. It didn't remove the tower. Okay. It's not supposed to remove the tower. So there's a chance that this is a map piece. Let's do it again. P. Okay, I'm trying to. Okay, it only removes. Yeah. Right. So why is that? I'm trying to think. Why is it only removing up here? Let's go down. P again. Yeah, it doesn't work properly. Yeah, it doesn't remove this side. It only removes. So if you look at our grid, it only removes 1, 2, 3. It misses this one, 1, 2, 3, and this one. Okay, so this is the player row -1. Player row -1. Player row +1. Okay, cool. I see why. We have to go to less than or equals to, and also here less than or equals to. Hope that was the issue. Now let's go to the center. Now let's go to the center. And then let's scan. Yeah, that's what they're looking for right there. So to scan is basically you are removing what surrounds you. And you're the last man standing, right? And then let's go again and
Last nice one.
yeah, but not in code, but here in the game. Yeah, so it did remove, so it's working fine. I'm assuming there are gonna be some trees that won't get removed because they are special, or they are what we call map pieces, because we hid them. Yeah, wait, was it here? No, it wasn't here. Let's try. Yeah, here's the map piece here. So that's a map. That's why that tree is not removed. So towers cannot be removed. Also, map pieces cannot be removed. You guys get it? So it can't remove.
I say
So
about
now, like, let's say now the player gets to what is this map piece. Is it now gonna like be replaced back with a tree or what?
So when it gets to a map piece, now you're just gonna pick it up. Nothing is gonna happen. So even there where the player was, there was a map piece. So you can collect it. You can just press something to collect it, and then you take it. You get points, right? So that's the logic for now. Let's do also add here for scanning. So also need more options. Yeah, but this was very difficult, guys. P for scanning. To scan, yeah, scan. So yeah, you guys are following?
these guys have no.
Yeah, we're following.
Yeah. So there's a catch, guys. There's a catch. I'm gonna show you what the catch is. So scanning and an area reveals the blah blah blah. These features may be empty or contain the previously hidden map piece. Scanning an area similar to removing the trace from the scanning range. Okay. Okay. Now, guys, I feel sorry for you because it keeps on getting more and more confusing and complicated. But just bear with me, please. So what they're saying here is that when you scan and there's a map piece, you must reveal it. You remove so you remove the trees, and then you reveal the map piece, right? So that's not all. What we did is not all. You scan, after you scan, you remove the trees, and then you reveal the map piece. Now we want to see the map piece that you have revealed. Right? Are you guys same page? Okay.
Sir,
Yeah.
I think the silence says it all, ne?
The silence is what? You guys
It says it all. It says it all, sir.
Okay, cool. I can try to make it easy, but unfortunately the logic part, guys, it's all you need to. I mean, what can I really do here to make you guys really understand what's happening, right? So
On Friday, they can make us make a game. Would it be like this also?
let me show you something.
With so much going on.
There is a lot going on. Let me show you guys something. Pictures.
This module will be the end of me.
This is how
Yeah.
a snake game is made. There's literally numbers that are moving around. So if this number moves here, this is gonna be 1. This is gonna be 1 plus 1, which is 2. This is gonna be 2 plus 1, which is 3 now. This is gonna be 3 plus 1, which is 4 now. 5, 6, and then 7, and then the last one they remove it. It's just 0. You apply the same logic. That's how a snake game moves. I'll show you guys one day how we're gonna do a snake game one day, maybe during holidays, because I mean this never stops. This whole thing never stops. But if you look at the snake game, guys, it's numbers. So food is -1, the head is 1, or it could be 9, as this thing moves, it's basically gonna say this is now 1, this is now 1 plus 1, this is now plus 1 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 until 8, and then this is gonna be 0. That's how the snake actually moves. When it gets to the food, now this is minus 1. We add plus 1. It's confusing, but it's how the grid actually works. With practice, you're gonna get it. Trust me, you're not gonna struggle. But then that's why I'm looking at this thing and I'm like, should I continue, or you guys still wanna digest, or what? But it's fine. Let's continue. So what they're saying, right, is that the player can initiate a scan, which is what we can do so far, right? Okay, that's what we can do. We can scan. Now we have the ability to scan. So the ability to scan is basically to say, okay, press P, P to scan, and then it's gonna remove except for map pieces. Now if I go up and then I scan here, it's gonna remove except for the trees. Let's go up again, scan, remove. There's a map piece. Now this was supposed to change from X into a map piece, right? And also remember, you see the battery level is 10. Every time we move, we must decrement that battery level. So I'm gonna come now to our move function. Where's the move function? Here's the move function. So if it's a valid move, where are we moving the player? This is where we're moving the player. So if it's a valid move, we should also do game world.drone.battery in battery level minus, because we want to decrement. And when you scan, you must take 3 units from your battery level. So you don't just scan, you have to also take 3 units from your battery level. Okay, so we're gonna come here where we're gonna scan, and then after we are done scanning, well, we can even do it here. So where we scan int game world.drone battery level minus, this time around is minus 3, it's not minus 1, right? When you collect, I'm also gonna do a function for collection. When you collect, it's gonna be 2 units. So now let's go and collect a map piece. It's inside our game world.
Just short gonna end.
So you see how many functions are here, guys? So many functions. And all of them, the easy ones are, you're gonna get the easy ones. Allocation, initialization, deallocation. Don't forget those ones, those main ones. Int rand, int to int, and then the rand. Don't forget these ones. Is valid move. Also don't forget the basic ones. Display, don't forget, easy one. And then move player is where we're gonna obviously try to climb a bit. So now I'm doing the collection. I want to collect food. I want to collect something. Okay. So guys, you cannot collect where there's nothing. Right? You cannot collect where there's nothing. It's but you can collect a map piece. So let's say now before I define the collection function, let's just run now to see if we are able to reduce. Every time we move, we must reduce this battery level. Yeah, it's fine, it's reducing. And when we scan, it must take 3. So let's scan. Did it take 3? 8 minus 3, no, it didn't take 3.
Yeah, it did.
Oh, it did.
It did.
Okay.
8 minus 3 is 5. 5 minus 3 is 2.
Oh, okay.
Yeah.
So when you scan, it must. So you see how tricky this thing is. So you must. Yeah, it's basically applying logic. So now to collect. Basically, it's simple. You just. So if I click on collect, you have to check what's currently there, right? So let's get the feature of where I'm gonna collect. So int row, where the player is gonna be.
This thing, so.
Int. So we want to see where the drone is. Int row, and then int call is equal to game world.drone int call. So we want to check the feature there. Int feature
Equal to
game_world.arr,
RC.
right? So if there's nothing, if the feature is empty or it's a tree or it's a tower,
Sir,
can we collect the tower?
sir,
Yes?
again, there's no R and C.
Oh yeah, I always make that mistake. So guys, just remember when you're writing your exam, it might complain. If it complains about R and C, just make sure that you fix that accordingly. Thanks for that. So now we want to check what the feature. So can we what can we collect? They're saying that the player can collect the features may be empty or contained previously. Scanning. Okay, moving a drone over a charging station recharges the drone, right? Yeah.
No, it's good.
Yeah. So guys, it's real. It charges the drone. So if you go on top of a drone, it's gonna charge it. I don't know by how many bars. Maybe one. I don't know.
If they don't specify,
You just
you
you get marks. You're gonna get you can ask the invigilators or your lecturer. They're gonna tell you. They're gonna let you know how it should be. All right. So let's see. Intros in call. Fine. Now if intros and in call. So now we check if intro. So no, let's get a feature of where the player is. So we get the feature of where the player is. Feature is equals to game world.
World.
Yeah, game world, AR world. And then intro. And then also in call. So now we say here if this thing is a tower. So if feature is a tower.
If feature is equal to a tower.
We increment. So we are getting something. We are incrementing the
int battery level.
battery level. Why is it not the int? No, drone dot battery level plus. So just to test if this works, let's just go to the tower. So let me just relax a bit on the collect. So let's go to the tower. Here's the tower here. So let's keep track of the battery level as I go. 1, 2, 3, 4, 5, 6, 7. If I go next, it should say 2, but then it's gonna say what? 3. Why did it say 3? Because it's subtracted and then it added afterwards.
Oh, okay.
Yeah. Because they didn't say that if you move to a tower, it doesn't subtract. Or they didn't even say how many units we are getting for when we get to the charge. Or maybe when they say it charges, it means it goes back to full bar, right? Yeah, it's possible.
yeah.
So it's possible that we are going back to full bar. So let's just do full bar. So yeah, these are the questions you could potentially ask your invigilators. Does it go to full bar? Does it go to add +1? And then they're gonna let you know. So instead of battery level ++, we're gonna recharge to full bar, which is basically battery level. So compile and then let's move to this tower here. 1, 2. It's 9. Let's see again. Oh, why does it say 9? It's supposed to say 10. Maybe it counts. Maybe okay. Let me see. Let's see why. Logically speaking, it's because we are subtracting after, so we can just move everything below here.
Logically speaking,
when it moves, it's gonna be there and then it's gonna reset. So let's try again. Try again, and then let's go to the next tower. It's 10. Let's go. We get a tower, 10. Then we get a tower, 10. You see? So that one is fine. We've covered that one as well. The recharging part, moving the drone to recharge the drone. Moving the drone over a map piece does not automatically collect the piece. Instead, the player must specifically choose to collect the map piece. Okay, cool. So now we need to collect but it's not automatically done for us because we must do everything ourselves, right? That's C++. I'm gonna take a 2-minute break to digest this. I want you guys to digest this. Just 2-minute break, and if you have questions, you can ask now. Yeah, and then I'll address them.
I just have a question. You see there where you changed it from R and C, and then you put int row and int column, and then I think Umukhao said that there's no R and C, but then up there by line 240 there's R and C. So I'm not
Okay.
quite sure about that
So
one.
he was saying that. So here you see we're using a for loop.
Yes.
Yeah. So a for loop has these variables R and C.
Oh, okay.
Yeah. So that's why we
Okay.
have R and C there. So it's one of those things where we're moving. Wherever you see two for loops now, Nkazimulu, just know that we're doing this, going step by step.
Okay.
So that's why there's R and C. Okay. So yeah.
Okay.
But in this case, we're just getting the player row and the player call, and then there's no need for R and C. We just use those. Yeah. Any more questions? Okay, do you guys want to proceed? Let me know if you want to proceed or want to breathe a bit.
Sir, just another 2 minutes.
Okay. Okay, cool. Okay, cool. Let's now actually collect the map piece. In order for us to collect the map piece, we want to first find it, right? So we first find it. After we find it, we collect it. So now, if we are standing here and there's a map piece, we are gonna collect it. But if we are standing here and there's nothing, you can't collect anything. Or if we are standing on a tree and there's no map piece, you can't really collect anything. So we want to check our feature. So what I said, we said we wanna get the player row and the player call, and then we check what's inside. You remember this logic? This line of code basically gets what's inside the world, and then now we want to check what's inside. So if the feature is equal to map piece, we want to collect it, else we're not gonna do anything, right? So how do we collect the map piece? We just basically change what's inside int row int call into empty, right? And then because we have collected it, and then what else do? We need to subtract 2 units dot drone dot battery minus 2.
And I will maybe not gonna let's say
Then
let
Sorry, what's that?
I was saying if like are we still gonna have maybe a function where like it will be like counting the number of map pieces left, maybe that we will enter inside the if statement.
You mean this if statement here?
One
Uh,
like that counts if
a map
there
piece
is
is
like
collected.
map piece left.
Or if
The
the,
pieces
the,
that
the,
are
the map piece
left.
is left. Okay, let me just see first what they're saying. So scanning is very okay. Move the drone over to a charging station. It recharges the drone. Okay, cool. Moving the drone over a map piece does not automatically collect the map piece. Instead, the player must specifically choose to collect the map piece. Okay. Doing activities in the drone uses up the battery charge the following way. Okay, cool. So there's nowhere where they said you must specify which map pieces were collected.
Oh,
So if they didn't specify it, don't bother. For now, you'll bother when you are done with your program and you're like, okay, damn, I'm done with all the logic. Now let me play around with it. But don't play around with it too much. Just zip what you did and that you feel like will give you marks, submit, and then you play around with whatever you have. So that at least. So now, we can collect the map. Let's try and collect the map piece.
Sir,
Yeah?
can I ask, no?
Yeah, sure.
Is there a way of like instead of saying in future is equal to map piece, we can introduce a integer, which is a number, and then we can make the user choose between 1 and 2, and then say if feature is equal to that number, then we collect. We do the logic to where we collect, or if we say if else, and then in the case of else, they choose to leave it.
So you want the user to collect or leave it?
Yeah, because
you-
the chooser must have. I think the chooser must have the option to collect if they want to.
Let's see. The player must specifically choose to collect the map piece. So moving the drone over a map piece does not automatically collect the map piece, right? It means that I can be on top of the map piece. If I move from then, that means I'm choosing not to collect it, don't you think? If I move away. So think of it this way. If you open a fridge, you can choose to take something out or close it, right? So now, in this case, it's like what you are saying is that I should open a fridge and take something out and put it back and close the fridge and go. Or like that's
No, that's not what I'm like.
what I say. Okay, because the player when they move on top of it, they don't know what if they're on top of a map piece or not, right? Unless if maybe it's
Okay.
revealed. But now let's say it's revealed, and you're on top of it. Do you want to collect and then it says are you sure you want to collect, and you say yes or no? Is that what you say?
No, what I'm doing is like giving the user can be like, okay, I'm opening the fridge,
Yeah.
but then there's something else I must do, so I'm closing it and then do something else and then come back and
Yeah, but isn't that you going on top of a map piece and then not collecting it, just continue going?
yeah, let's say in this situation,
Yeah.
obviously there's a map piece after they scan, and then let's say maybe there's a tower next to it and
You
the
wanna go to the
battery
tower?
level, yeah, the battery level is too low.
You can
You
just
see?
pass the map piece and collect it and recharge, and then you go back to the map piece. You can pass on top of it, basically.
Okay, what if the battery level is like 1?
You can just pass.
Oh.
Okay, what I'm saying is this, right? So, let's say, right let's say on my way there. Let's say here is the map piece, and here's the tower, right?
Okay.
I'm gonna go, and then when I get to the map piece, I'm not gonna collect it. I'm just gonna be on top of it. So I'll just go charge and then go back and actually collect.
Okay.
You get it? Like so,
Okay.
I can be on top of a map piece and not collect it. I have to choose. I have to press something. Press C to collect. I press C, I collect it,
Oh,
and then I go. Or I can just pass it. You can basically pass the
oh,
map pieces.
I get it. I get it.
Yeah. So yeah, no. Does that answer your question? Are
Okay.
you sorted now?
Yeah, I'm sorted. I'm sorted.
Okay, cool. All right, so we're gonna collect map pieces now. We're just gonna try to see if it works. Let's collect the map piece. Okay, we need to collect. We can't just say let's collect. We need to have the collect option. So I'm gonna go to my options and then I'm gonna say case collect with L for collection, and then I'm gonna do this break. So now I'm just gonna say collect game mode, right? And then it should collect. So now I'm gonna go to my main menu, L for collection, and then it should move player, game mode, and then option. So this one is for collection, right? So let's just try to see if it works. How we're gonna know that it works is if it's gonna remove the map piece, but we need to first find those map pieces. And okay, right now there's not a lot of them. Let me just do this so that it's a lot of them. Let's put how many map pieces? Map pieces, the last one. Let's put at least 10 or 10 map pieces. Or 13. Let's put 13 map pieces. So run it now. I forgot to put an option for collection, so let me also put an option for collection. Here we're gonna say collect, and then we're gonna say, and you know, another smart thing that you would do, you would enable collect if the player is on top of a map piece. But that's a story for another day. Let's just work with what we have. It's already confusing as it is, right? So let's just keep it simple. So now let's try to find the map piece. Let me scan here. Wait. So it actually crashed. I'm trying to see why it crashed. What did it crash? Okay, let's try again. There's a reason why it crashed. I'm going to tell you guys now. Scan. Okay, here's a map piece above me, right? And the drone level is -2, just like that. It's fine, we'll fix it. So now if I go up, I can choose to collect it or to leave it, right? So if I go up and I say L for collection, press enter, it exits the game because of L has no break. So don't forget breaks. If you forget a break, it's gonna go all the way down. Let's try again. And then let's scan. Okay, there's a map piece and there's another map piece. So if I collect the map piece, go down, C for collection, L for collection, it should be collected, and then it did -2, that is fine. If I go up, it's gone. You see, it collected that piece. So I can still also go up to this one and then also pass it. You see what you're asking?
Okay.
And then I can go back to it and like collect it. So let me just charge and then go back to it, because that's what you're saying. And then let's collected, and then so you saw now we can collect the map piece.
So
Yeah.
at this point, like, can the battery level be managed that like it ends at 0 or something? Because I can see it's going to the negative
that's
side.
gonna be so we are done with this moving part, right? So when you are doing this step by step, don't worry about the battery. Just know that you have a battery, and you don't confuse the logic. Do it. You saw how we did everything step by step. I didn't go and now move a player when I was still busy random rows. So you should just do everything step by step if you want to have peace of mind, right? So now we come to the updating part, right? There's a command line define percentage chance. Then now we're gonna use our command line define percentage chance that each individual charging tower may be destroyed by an indigenous people living in the jungle. Cool. So what do we do with this? What are they saying here? I don't know. Oh, every time you move the player, there's a chance that the tower might be destroyed. They said each tower might be destroyed. Dang, this is crazy, bro. So guys, listen. Guys, listen.
Hi.
So guys, what they're saying here is that when you move, there's a chance the tower might go down. All of them, there's like a chance it might go down. So yeah, so okay, cool. We need to get like the update function. Update function, we're just gonna say update. Let's define our update function. So after the collect, let's just say we have a void update function. Game world and then game world. So the update function basically will run every time the player moves. Every time there's a movement or every time the world updates, it's gonna run. So I'm gonna come now to the after collect, because I put it after collect, and then when collect closes, I'm gonna put my update function. So what happens in the update function is that there's the chance that you remember the chance that we defined here in the command line. So this chance, right? In this case, we said it's equals to 50% chance. So there's a 50% chance that each tower might go down. Each tower, not one tower. Like basically, each tower might go down. So how would we do this? How would we go about like attacking this one? So this one, basically, what we need to do is to go through all the towers. So given that we have a world like this, we're gonna start here and we're gonna go check, and then we find the tower. We're like, there's a chance it might be destroyed. So there's a chance. We calculate our chance. If it's in our favor to destroy the tower, we destroy it. Like boom, it goes away, and then we go again here to the second one. So we go here, destroy this one. If there's a chance it might be destroyed, now it goes here again. Start here, tower. Chance it might be destroyed again. We do that, continue, or for all the rows. You guys get it, for all the rows, right? So you guys can already imagine we're gonna need 2 for loops, because like you saw how I was moving in the world. So yeah, we're gonna need 2 loops. So let's do our loops. But you are gonna get marks. You just relax. You are gonna get marks as long as they say, okay, this student was trying. She saw that, okay, he or she saw that they needed to use 2 for loops, even though the logic doesn't make sense. Let's just give them something. They're gonna pass. And then R is less than game wall dot int rows. Then R plus plus, and then for int C, same applies to C. Game world dot int calls C plus plus, and then so now we want to look for features. Now we look for features. So int feature, you remember what the feature is, right? It's basically what's inside. ARY game world, ARR world RC. Now this is where we use RC because we have the 2 for loops. You see?
Yes.
Yeah, so if the feature is a tower, there's a chance it might be destroyed. So now we're gonna come here, and then for the chance part, we just say if the chance part is simple, just say if get random. So let's just say chance here. Int chance is equals to get rand. Then chance is from 0 to 100, because obviously percentages, and then we say if our chance is less than the chance that was given, game world to int chance, we destroy that tower. game world.arrworld.rc is equals to empty. So we destroy that tower. So it's as simple as this. This one, our update was simple. So you just destroy the tower like
Come on, man.
so equals to
Where's
empty.
that?
So since you are here, you're saying from 0 to 100, but then they said that there is a command line defined percentage. The command line was not like
50.
5 or something.
It was 50. So that's also another good question, right? So with chance, like, let's look at the chances. Like, what's a chance? Like like when they say what like there's 50% chance
Mm.
of something happening, right? That means that if I generate a percentage from 0 to 100, and that percentage is above 50% or equals to 50%, that means that it's
That's
gonna
like-
happen.
Yes.
So in this case, I generated a number between 0 and 100, and then that number has to be less than the chance that we passed through, or equal, I think, less than or equal. So we said 50% chance. So here, what are the how do we say chance? It's a number. We generate a number between 0 and 100. That's gonna be our chance, right? And then we compare that number to, and that number must be less than or equals to the chance that we defined.
Yes.
Does it? Am I still losing you?
No, I get it.
Yeah. So the number, so that value here,
so-
that value, yeah.
Can you go? Yeah. It you said in chance in the command as a command line argument. You said it's 50, right?
Yeah, 50%, yes.
And then yet, from the number that you're getting from the get rand, which is between 0 and 100,
Yeah.
why are you saying that number has to be less than 50 in order for that tower to be destroyed?
Yeah, that's a good question. It has to be greater, ne? Should it be greater?
It shouldn't. If it's less than or equal to, shouldn't it be less likely to
Yeah.
happen?
Definitely. Yeah, true. Okay. Yeah, you have a point there. So let's use, actually, let's say greater than or equals to. So let's use like our logic now. Let's go to chance. We said there's 50% chance something might happen, right? So, and then we generate like that chance. So we generate our chance, and then we find that the chance is 40. That means it's not gonna happen. But if we find that the chance is 50 and above, that means it's gonna happen. Yeah, you have a good point. Yeah. So it's right. You're right what you're saying. So it must be greater or equals to. Correct. So if our chance lies in there, that means that okay, cool. We are gonna destroy the tower. That's our update function. Okay, cool. Let's see if they get destroyed.
This one. Just
Let's see if they get destroyed as we move. Okay, now, but we're not using update at all right now. So we have to update. As soon as we move the player, we update. So where's the... So you might be going for a tower and then it dies before you get to it, sadly. So here, when we are doing the is valid move, when we're checking if it's a valid move or not, if it's a valid move, we are gonna update our game world. So let's compile and run. So now we are looking at our towers. They might die. I'm trying to go to this one. Up, it died. You see, it's like a 50% chance. This is like, what kind of game is this? Let's try to go to this one. Right? Down. Yeah, at least we got that one. Let's continue. Let's scan. Shit, the tree died also when we were scanning. Yeah, but fine. We now try to get to that. We died also. So let's see if we can collect. Yeah, we can collect. Yeah, but you see, all the trees have died after 5 moves because the chance is high. But they can decrease the chance here so that it's low in the command line, so that you can keep on playing until you win or something. Okay, so we are done with the chance part, and then now we're gonna look at the end game function. So now we have void end game. Finally, if you guys get here and you're still okay, yeah, wow. So you get to end game, and then, well, the game must end. I doubt you guys are gonna play your game when you're done coding. The way you'll be so tired. So let's end the game now after update. So how do we end the game? They're saying the game succeeds when the player successfully collects all the map pieces. The game fails when the drone runs out of battery. So two options here for the game to end, right? So end game function is not gonna be a void, it's gonna be a bool, because we wanna know if the game is ended or not, right? So is end game, and then we just say bool, right? And then we're gonna come here, say bool instead. So yeah, the end game part is easy. We're just gonna say when we no longer have map pieces, the game ends. So okay, I want to make this easy. There's so many ways we could do this, but we have to find the easiest way. The difficult way, the most difficult way to do it is if we check, go one on one, and then we get map pieces. We are calculating them as we go. We're calculating them as we go, etc., etc. Right? That is the most difficult. That's the difficult one. That's difficult to do. We don't want to do that. Instead, what we want to do, let's just do the first one first. So the game succeeds once the player collects all the map pieces. We're gonna look for succeeds after. And then the game fails when the drone runs out of battery charge. Okay, cool. So we have two states. We have the success state and we have the fail state, right? So bool won't work because bool is either true or false. We don't know if it's really a success or a fail. So we're gonna come and do our state somewhere here for our fail or pass. So enum end state, which is the game state, and then we're gonna say success or fail. So, and then we're gonna, inside our game world, we're gonna have the state of the game. So the state, the int state, right? So we're gonna have success or fail or running. So the game is still running, or you still playing the game.
Maybe he's still typing.
Right. So initially
And,
the game will be when we initialize, the game will be running.
Yeah, I keep turning on that box.
Game world dot state, it's running because the game is running. And then when we run out of battery,
Time is mine.
let's say in, so on end game, we're gonna say int, right? This is the end game part, and then also gonna say int here, and then instead of end game, we're gonna say the game state. We're gonna get the game state, and then also gonna get here game state. So we're gonna say that now, how do we know that the game, what is the state of the game? If the pieces are collected, or if the game fails when the drone runs out of battery, right? So we can say if a drone, like if game world dot drone dot battery level is equals to 0, we're gonna return okay, we're not gonna return. Oh, guys, this one is it's a bit confusing. Let me see. We're gonna return. Do we return or do we save that value? I'm trying to see. Well, how do you think we should handle the state, guys? Should we return or should we store that value?
Should we return or do what?
So in terms of the game state, right? Do you understand what I'm trying to do now? Do you understand what I'm trying to do?
Yeah, you're trying to see if the player lost or won, something like that.
Yes. How do we check that?
If the player wins, right? We're gonna if the battery level is 0, then in return game lost, state lost.
Okay, let's say fail because we defined it as fail, and
Okay.
then the win part is if they've collected everything. Dot the map pieces is equals to 5 or something. Then we're just gonna return success. Else we're gonna return running. The game is still running. Alright, so here we come. Now we're gonna check.
Sir,
Yeah.
what did you define the battery level? I mean, how much did you apply to the battery level?
10.
I think for the case for the if statement where like you saying game one,
Yeah.
yeah, I think it should be the full number. Eh? No, never mind, never mind.
Oh, okay. So now we'll need to find a way to know if we have won or not. I'm gonna come here. I'm gonna say int game state game world, and then I'm gonna say int state. So
Oh, the five.
if state
Okay, never mind.
is not equals to running, then bln continue is false, and then we're gonna come here and then we're gonna see out the state, right? So let me just say thanks for playing.
Yeah.
Thanks for playing. Obviously I should say you have won or you have lost. I'm gonna do that. Just compile. Why is it complaining? Game state. Okay. It's complaining because of what? Its state is inside here. Okay. So I must define the state again. Okay, I can do that. And then run. So now let's get the battery to 0. Thanks for playing 1. So when the battery level gets to 0, it does work. So what we need to do now is just to print the world once more, so that it shows 0, then it says game off. For those who are lost, guys, you're gonna get it with practice, right? You're not gonna get it all at once, but as you practice, you're gonna understand what's going on. So let's try to get the battery level to 0 again. There, thanks for playing. And then obviously I said 1 here. I should have said failure or something like that. And for the other one, the game succeeds when the player successfully collects all the map pieces. You guys can do this one, right? Silence.
Sir,
Yes.
why did you say if? Oh, this. I'm looking at the if statement where you said the state is not equal to running. So meaning that the game is
What does it mean? Does it mean that the game is no longer functioning, or
So if you look at the state, right, we are either
yeah,
at running, fail, or success.
yeah,
So initially, when you launch the game, it's running
uh-huh,
now.
yeah,
When you run out of map of battery, it's gonna go to fail state.
mm-hmm,
When you win, it's gonna go to success state.
yeah,
So what I did with those values, I went to my function to check what the game state is, and then if
okay,
you ran out of battery, I'm gonna say it's gonna return fail. If you got all the pieces, it's gonna return success. Else, it's just gonna say the game is still running.
okay.
Yes.
So
So
that,
when you think of a snake game, the snake keeps on running until it bites itself or it hits the wall. So think of that running as the running, right? And then when it bites itself, it's fail state. When it eats all the food and there's no more food left, it's win state.
okay,
But you can apply any logic. It's just that I thought of the easiest way of doing it, which was this way. And then for this one here, this is a bit tricky, but it should be easy. You guys can handle it, right? The winning part. So our game, we can only lose at this point. As soon as the battery level gets to 0, we lose. Thanks for playing. You could have just said you lost or something. So you can also use your state to say that. So if state is not running, okay, cool, you end the game. And then, so here you can say if state is win, it's fail. Instead of saying thanks for playing, you say you lost. Say you lost, you lose, and then else, if state is success, just say you win. You win. And then I'm gonna remove that. You lose, you win. So it should be your game now. And then if you look at it, if I lose, you lose, right? And then it ends. And then if you win, that's when you collect everything. So you guys knows how to collect, you know everything. You just need to implement the collection function, and then we should be able to see that you win as well. And I'm gonna give you this code to continue from. So do you think you can manage to do this one last bullet here? The game succeeds when the player successfully collects all the map pieces. I showed you guys how you could do it. You could loop through to calculate the number of map pieces that are there, or you can use a different way. So are you guys okay?
We can try.
I mean, I already gave you the answer. I just want to know if you guys can be able, or you want me to do it for you.
so you're doing it for the case where you succeed.
Yeah, because the fail part is already there. We know that it's gonna fail if you don't collect all the map pieces and you run out of battery. So you're gonna win if you collect all the map pieces. It's basically the opposite. So you would apply the same logic. You just need to know how many map pieces are left. So I just said 5 here, just so that you know, but then I want you guys to actually try to think how you were going to implement this. It doesn't even require for loops and anything. It just requires you to apply logic, and then after that you are done. So hopefully you guys can do that. I trust that you guys can. It's one bullet out of all the, we've covered all the bullets except for one, which is this one here.
So we put it in the very same function for game state.
Yeah, the logic must be here. So you see here where I said if game world dot in pieces is equals to 5, I must change this so that it counts the number of pieces that you have collected. Just something to think
Basically,
about.
must output the number of pieces that we collect.
No, so if all the pieces are collected, you say
Yeah.
return success.
Uh-huh.
Basically, yeah. So this is something that you can think about and obviously try to make. And then, yeah, if you struggle, just ask me and then I'll share with you the code. But I feel like this is at least one challenge you guys should try to like to get. But you would have gotten a distinction with the code that I have here. You guys agree?
Of course.
So what about the bonus marks? I saw somewhere also that when, like,
Oh, you're thinking about the bonus. Okay.
I don't.
Okay. The bonus it's usually
You're fighting.
they tell you what's I don't know what was the bonus for this preg, but there's actually the bonus section, right? There's actually the bonus section. So they're saying here C7 and B are evaluated differently. We will not consider sessions yet, and we will not consider bonus marks yet. So here there are no bonus and there are no sessions for this practical. But bonus marks, Nkazimulo, ne, they usually specify there's gonna be a bonus section. It's not gonna be in the rubric. There's just gonna be a bonus section here where they say that okay, do so and so. Maybe use structures or use record or use whatever. They're gonna specify on the paper itself what the bonus is. Are you happy? So we have covered the boilerplate code, the coding style, the functional abstraction, which is basically, I wanted to tell you guys at the end what functional abstraction is. This is functional abstraction. Having different functions doing different things. We're not putting everything in one place. If I look at the memo, you guys are gonna see the memo is quite a bit different from how I did things with you guys. I don't have the memo here on me, but yeah, if you look at the memo, how I coded and how the memo coded, it's way too different, but we are all achieving the same goal, right? It's all about which code do you understand better. Do you understand the memo better or you understand this code better, right? Reduction of repetitive code, your to int, your get rand. There's no code that I repeated here. I doubt I repeated anything. And separate compilation, your header file and your CPP file, you get your marks. User interaction, the menu system, 5 marks. We have the appropriate use of input, output and error streams. We'd get 5 marks for that. Command line argument, you get your marks. Error handling and assertions, they said they're not going to consider them in this case. Pseudo random number generator, 5 marks. Dynamically allocated two-dimensional array allocation, initialization, deallocation, 15 marks. And then the important part is this one here. You don't have to be 100% correct. Just try to do something. You're going to get the marks. Algorithm implementation, logical correctness, 5. Effectiveness or efficiency of approach, 5. Correct use of approach selection. Iteration structures, 5. Correct output, 5. We do have the correct output. Usually in most cases when the assistants are marking, as long as they can move your player and then they can see this happening, they're not even gonna, okay, I was a marker before. We don't usually check your code if it's moving and it's doing the most basics. We could give you something like 19 if maybe you can't really collect but it can move. You can get 19, 18. They're like they are not really strict when it comes to marking, because these practicals are marked by the assistants. They're not marked by the lecturers. So just keep that in mind. So and when an assistant is marking close to say 10 assignments like in a day, or I don't know how long they take, but usually they give you like a pile of papers. You have to unzip, you have to check the CD, you have to capture the marks. So they do get tired, these people. Sometimes they end up not even reading your code. They're just gonna do this, run, and then they do this, and then they say, okay, it's running 18, 20. You know, like, so you can get away with a lot of things. That's why when the marks are released, there's the first marks for unmoderated, and then there's the moderated ones. So yeah, just do something on this part: algorithm implementation, logical correctness, effectiveness, efficiency of the approach, correct use of appropriate selection, iteration structures, correct output. Just know that C10 is basically what we covered when we came back after the initialization. When things were getting to these bullets, this is just logic. What I told you guys, logic. Do something, you're gonna get the marks, but also don't do the wrong things. Obviously, do something that at least sort of like makes sense in your head, and then you submit, you will get the marks. So I would easily get away with not having the fail state in this practical, right? Because the assistants won't usually like move until they win. They won't try to collect all the food so that they see that all the map pieces are collected. They'll just run and see, okay, your program is running, they are destroyed the towers and whatnot, and then they just give me like a 20, and then they move on to the next person, because they want to finish marking. They don't want to stick to one person's preg and wait there marking that person for, you know, checking each and every function. Does it make sense? Because also when they read the code, they will get confused, right? If they read your logic, your move player logic, and you have these things, they're gonna look at them, but they're not gonna really see, is this really like plus plus? Should it be a minus minus? No, they won't check that. As long as your code shows the world and it moves around, you're gonna pass. Trust me. So yeah, that's it, guys. Just gonna stop the recording, and then